Hello, everyone. How's it going? Our volumes are right? Everything good over here? I don't know what happened to the chat on the overlay. I broke something, which is not surprising. Oh, okay. I think. No, I have no idea what happened, but something happened. Did I break the overlays? Properties. God damn it. This is what I get for trying to fix things last minute. Copy URL. Come on. Refresh. Do not get why the chat's not here. Maybe it'll come back. Okay, so we have the coming back soon screen. Starting screen. I don't know. I can fix that some other time. Let's start. Oh no, my overlays. This is like the stream version of my underwear. Yeah, this is a cool little thing. All right. I'm gonna hide the viewers. We do want to see how many hours we've been streaming. So I don't think today we'll we'll do as much as last time yesterday. I think a 15, 16 hour stream is way too long for you, but also for me, because I need to touch grass sometime. Right, I didn't even prep this up. Okay, environment looks all right. We have the PR we want to look at right now. I did already have a tweet somewhere here. Yeah, this one. If y'all can retweet, that would be amazing. Hopefully we get some new people in the stream looking at OCaml for the first time. Now, Leia, I'm ready. Okay, I'm ready for the cat as well. I got a monster. My phone is here. Let's see if I can actually look at the stream on the phone. Twitch. Volume's low. But we are live. Stream manager. Cool. All right. I see the chat and stuff. It's not the best in the phone, but it's better than nothing. Okay. Where were we? We just tweeted a moment ago. Now, Leia. Now. Zero patient today. Right. So yesterday we published Riot Series 6. We made like grade updates for Series 7, 007. I think it's going to be a fantastic release. We'll have vectorized IO. I mean, seriously, if we go into... Okay, let's see if I'm already updated here. Nope, still not approved for sponsors. I don't know why I've done, but they don't like me. Changes. Oh, we didn't update that. Okay, I'm getting the last commits here. Yeah, so this is 006. We introduced a couple of things like IO module for doing read and writes on C structs, so they're going to be crazy fast. And we exposed a file module to do reading of file descriptors and doing vectorized ops for reading and writing files as well. We have some tests for that. Major quality of life update, which is if the main process dies unexpectedly, right? Like with an exception or something, we kill runtime. And this is, I don't know if this is the right decision, right? It's just a very small change. But it is very useful one. Because usually when you start your app, right, if you're writing a test or something, like, let me just show you one of the tests here, like the IOV writing test. There's some setup, we do some things, and eventually, right, like either we shut down nicely manually or we crash, right? If some of these things, especially this result get okay, crash in here, then we definitely want, because it's a test and we're just like hard coding a single function to be the application, right? Then we want this entire thing to crash as well. In other examples, like if I go to the application example, I think we have one here, application test. Then I think it's not as important. Like the main function is hidden from you, right? And it's implemented within Riot, and it's unlikely to fail, or to, I mean, maybe not. It really is just speeding up more work, right? So it's just waiting on all of your process, like on telemetry and logger and the test app here and so on. So I think this will be fine. Actually, I think it will be fine after talking about it. Anyways, so a lot of nice things happening in Riot here. I have not measured the speed improvements that this would give to some other things like Atacama, right? We have not yet updated Atacama to work with that. Oh, we have a pull request. Oh, es Morimoto. Adding a, oh, let's see this. How do I do the bridge thing? This way? I don't see the image though. I guess it's because it's in the same PR. Align center and everything. Yeah, this looks nice. Does the image have a white background? No. Okay. Cool. Look at that. Socket pool for OCaml. All right. Approve. Let's get this merged. And we're gonna merge the pull request. Docs, add hair image. Actually, I'm just gonna copy that. I don't want to author my own thing. Confirm merge. Cool. Does that work? What? Pretty nice. And we're gonna do the thanks. Thanks. Does Sora have a Twitter account? Yes, it's Morimoto. Oh, Nate Codes. Do I follow them? I thought I did. Okay, so we have Sora here. We merged that. Perfect. No, crap. We wanted to still stick on Atacama here. I'm going to forget otherwise. And we have an issue. I think this is mine. Okay, signature mismatch. Yeah, that's not a problem. Yeah, so we don't know how much faster it's going to make the socket pool. Because right now the socket pool is doing some very dumb things. So it could be a lot better. Anyways, so we went through that publishing, right? And we tried to publish at the Atacama 004 before the 007 improvements, right? And we started prototyping a new HTTP client, and we sort of pulled the name, and Blink was the winner. Thank you, Dylan, for suggesting the name. Super cool name. And we have Blink somewhere in here. Doop. Blink is actually inspired by Elixir's Mint, which is a low-level HTTP client that can be used for building higher-level abstractions. So essentially what we want is to be able to connect somewhere, right? Send a request there, right? And then be able to stream a response back. and the stream may be sort of very very short lived because you just call it and then you get all the data you need, right? Or it may actually live a long time, right? Because you need to maybe get something really large, like stream a file or something, right? And then you want to be able to call stream on your own, like schedule that however you feel like, right? Maybe in a hot loop in your application or something like that. But this is all vectorized I/O, which is super cool. Privan, yeah, how's it going with the HTTP client? Hey, Mr. Glitchbite, thanks for the follow. Ooh, Dylan, I think you're gonna love this if you're still hanging around. Some time ago, a good friend made me a sketch of chibi icons of myself as doing different things. And I realized I am underutilizing that. Like I usually have it like a sticker pack in Telegram or WhatsApp, stuff like that, right? But I could use it on stream. So I started putting them for different things. So if y'all stick around, right, and we get like, I don't know, follows, some subscriptions, or maybe a rate or something, then hopefully you'll see some of those popping in and out. Also, if y'all want some music or whatever, just drop a suggestion, and I'd be happy to switch to that. Thanks, Glitchbite. Yeah, I mean, Metallica has been one of those. It's the band that taught me English, really. Like I learned English listening to the Black Album. Uh, I think it's just called Metallica, right? Yeah. I mean, Enter Sandman. Like that was this song I learned English too, right? Yeah. To me, my favorite period is like Master of Puppets, and then I really like the Load album, just like more bluesy, more. I don't know. It's a different Metallica, but I enjoy it. You got any favorite songs? Privan, we're not doing that. We are not turning RAS code into a into a camel. Oh wait, I wanted to try something here. Do y'all see the difference there in the camera? Like if I do this, then that's the lighting I actually have right now because I'm in a kitchen, right? And this is the lighting that macOS does for free. Fuel, yeah, you missed it. We started the stream with that. It is an excellent song. Whiskey in the Jar also an amazing. That album is fantastic, isn't it? I think I'm gonna cue that album afterwards. Let's just do this a little bit. Metallica albums. Just want to show all. Where's you? No, I just want the cover view. Garaging. There you go. I don't love every cover here, so we're gonna skip a few for sure. But there's like Sabracadabra. It's electric. It's amazing as well. I really like Astronomy. Honestly, I string around. Like yesterday, we listened to like a ton of Ren, and it was amazing. But you can see here, like between my playlists and favorite artists, I have all sorts of like Nep, like a very very indie artist. Like she makes really cool like what is it like quirky little songs. I love them. Iniko, the XX, Rush, favorite band of all time, Rush. Rhapsody and Halloween yesterday as well. Anyway, so I'm just gonna cue this for later. Cool. I'm just gonna put that on the side. I will say though I'm more of an album person than like a single track person. So if you do want to recommend something, if you have an entire album, I'm more than happy to just like drop the album there. Okay, so today we want to do. Oh wait, right recap. And to get Blink working on HTTPS, we actually needed some certificate stuff. So we started prototyping a CH store. Blink, where's Blink? And yeah, we have a CH store here. And this is amazing, right? So this is the same PEM file that is used in the CH, the Castor package, right, in Elixir. But the existing infra, I don't know anything about security, right? This is not my forte. The existing infra, OCaml for doing these things like X5 and 9 actually required us to pass in CRT files, right? So we had to convert that PEM file, decode it somehow, right, into a PEM, into a single CRT. And we could have depended on the CA search package, right? POM. But this one has a bunch of dependencies and stuff. Like, I'm okay maybe using that in a larger application. But like, I don't want to pull in like logs and fpath and ptime and stuff like that, right? If we're not going to use it, especially when Riot already has some of these things, right? And it already includes some of these things. So I would want to sort of have the smallest package possible. And when we look at the CA search in Elixir, where the hell is that? Elixir Mint Castor. This library is so tiny, right? The code is literally just like, this is the module. It has one path. So all the code is just that PEM file, right? And I'm like, how can they do that? And we need a library with dependencies to do this, right? There has to be a trick to this. So I fed OCaml Genie, the custom GPT that I've been working on. OCaml Genie here. Dropping link in chat. How do we do this? Twitch. All right. Yesterday I had the chat popping out, right? That's very useful. Yeah. And we fed the code here, right, to this GPT of this library, right? CA search, and we asked it to extract just one function, right, that will take a PEM file and combine it into a CRT. And it gave us this thing, right, that we can just call like on module, like, I guess, loading time, right? So now we just have one certificate. It's exactly what the OCaml infra needs, right? And that worked. It was insane. It's like you just drop it there and it does the thing, right? And we were able to actually get content from a website, but it didn't work for common ones. All right, so that was that. So I want to publish that package. Like, I want to publish this module, right? After we make sure that it does work with everything else. So people can just rely on this. So do you need CA store? You don't have to figure out what the right one is and based on the operating system. Here is a trusted chain, right, that we can use. And this was created by Mozilla as of some time. And I'm sure they have an updated pipeline, right? No, it's not that way, man. This is public stuff. Public certificates for clients, right? And I'm sure that the Elixir people, right, they have maybe a pipeline or something here for fetching and publishing, like, see here, those certificates. So we could do something like that. Hey, Privan, yeah. A mixed task, perfect, right? We don't really have something like Dune tasks yet, but boy, wouldn't that be amazing, right? You had me checking on the phone what the hell I was streaming, just to make sure that I am actually streaming what I think I am. Anyways, so, right. That means now we can do this stuff. So first of all, we're going to fix the publishing issues, right, that Marcelo Seri found in the packages. I may rant about this, but we need to fix it so we can publish 006. So we'll start there, and I think they're here. Yeah. So Marcela was kindly pointing out that the upper bounds of Atacama, right, 002 and 003 are breaking with this release, right? Because these libraries just go like, oh well, I need a version of Riot that's higher than, right, and I personally, I don't mind. This is still 0 software. Like I would expect this to break, and if it breaks, it's like that's fine. Just get the latest version, right? Once we have like a 1.0, then okay, well, we need to worry about compatibility and all this stuff, right? But right now, what he's doing is great, right? And I love that he's spending time in like this time of the year, even holiday season, right, to look into this. But I think the practice in general is flawed. It's like we should treat zero libraries as like, well, it's zero. So if it breaks, right? All right, so that means we will have to go into the code here and search for Atacama. By the way, you can do this as well if you try. And we'll need to find a couple of these packages, right? And then open the OCaml files. And in here, we'll need to modify this constraint. Yeah, I understand that, Dave, but that doesn't sound like reasonable. I disagree with that. I think it's the wrong thing to focus on. 1.0 and above, yes, please do all the checking you want, but until then, just let me iterate. I want to iterate fast, find a good sort of API to be able to stabilize the API, right? But focusing on this stuff right now means like I cannot move fast enough, right? I need to focus on this accounting thingy. All right, so we're gonna do, I think the right syntax will be, actually, we can just probably do equals there, and that will be fine. So we're gonna make a new branch. I think maybe it would be even easier to just go to the branch here, right? Copy that, and we're gonna go to repo, OCaml, OPAM repository, right? And then check out this branch. What? We don't have the branch? We should have the branch. Oh, right. Get rid of that. Glad to have you on board, yeah. Honestly, I feel like doing release should be completely automated. Right now, there's this manual merging step that I don't think makes sense. I disagree with it. I understand why it's here. I don't think it's gonna, I think this is the wrong thing to focus on. Just let people publish things. Okay, so we have that there. And clean, I think GFX was it? FX? Cool. Fuck it. Just gonna remove this. So all the stuff that we have here was a little bit of shell code to get all of the URLs for all the packages, download them, untar them, concatenate all of the code and the docs, right? And chunk that into files that we can submit to a custom ChatGPT. I think, unfortunately, there is not a lot of info on how custom GPTs actually search for the information. But what I do find, like if you go into the custom GPT link I dropped here, right? Where the hell is it? And you say, according to your knowledge base, right? What is a good hello world in the Riot framework? And this goes into analyzing, but if you look at the script that it uses, right? It actually, okay, this is much better. What I was seeing yesterday was that it tried to actually read all of the files, right, into memory. And we're talking about like, I don't know, 2.5 gigs, right? And then once it found something, it returned the first 500 lines of that something. I'm like, but that's like, how is that even relevant, right? You have a 500 meg file. If you find something at the end, give me a window of context around that at the end. You know, like RAG, retrieval augmented generation. So this one might work, but the script that he was using before, if I don't even know if it's using the script, honestly. But the script that he was using before did not work at all. It just timed out constantly. So I think that we definitely want to do something better than this. We can still use GPT-4 for the actual generation part, but to be able to do semantic search, right, over the code, all of OCaml, we definitely want to have a pipeline where we do the embedding, we do the chunk, and sorry, I touched the cable here. And it's not going to be that expensive. I just embedded, I don't know, 150,000 paragraphs of Swedish law and other laws, right? And I think we spent like $8. So I'll be more than happy to pay that to do that embedding, right? But I would not build this with OCaml right now. I think we are not there yet. I know some people are super proficient with their stacks and can definitely do everything, and that's fine, right? But I would want a project that we can get up and running in an afternoon, right? And it will just run. Like the focus here is not building that in OCaml. It is getting the data into, right, a RAG system. Well, once we have the RAG system, be my guest, use a RAG to rebuild this like Bootstrap, right? I would fucking love that. I think that would be so much fun. Yeah, okay, so as you can see, this is still analyzing. This is still removing. There's so much stuff here. Why is it so slow? This is not what I want to spend my time on. Come on. This should be fast. I think I'll just... I can't even do that because I have to wait on the file system to be updated for... Okay, that worked. Cool. Riot. Why don't I have that here? Remote, fork, add fork. Where's my fork? Here. Yes, Priman. Exactly. All right, so we're here now. We can go at the comma 001. That's fine. At the comma 002. No. And we can just do equals. The comma 003 equals. And we're probably gonna have the same problem with the next version of Atacama as well. Use fixed Riot versions. All right. So we go back into the pull request. OCaml. You can close that. Here I go now. Oh, we're already playing Garage Inc. How does the little icon look like, by the way? Turn the page. Is that nice? On the top right? I have been spending a little bit of effort in the stream. All right, so this will take a while, so we'll leave it there. And in the meantime, we'll check for the Atacama PR. What? Oh yeah, okay. This is definitely gonna fail until we merge Riot. Cool. So this will run here. Let's tag Marcelo. Thanks for bringing this up. I've updated the old that comma 02, 003 open files to have a fixed version of Riot. Instead, Merry Christmas, everyone. God jul, gott nyår. Should be then, you know. Thanks and Merry Christmas. Or Happy Holidays, actually. I don't know if they celebrate Christmas. Sparkles. All right, we did a part there. Next up. Right. So, Marcelo also suggested moving Blink to GoHTTP's low-level parsers. Aw. 100%. They're all very fast, while young. Okay, folks, let's do some code. And it's going to be open. So last we tried, right, we were making a test that would fetch abstract machines. And it actually manages to connect through TLS, which is great. But then it fails. And it fails during the parsing. So in the stream, here, and that's sort of the data type we have, right? We will get a list of some of this stuff. It could be like one headers and then like status and then like many pieces of data, and then eventually it will be done. So you can, pull it at will. And the error here is on line 32 of the test, which is what? How could there be an error there? Pattern match failed. Oh, okay. I think I know what the problem is. There we go. So this is missing some other things, right? What? Seriously? Like that? Oh, okay. Yeah, that makes sense. So this will be parts, right? And then we can do let warning -8 parts. And great. So now we'll have a different kind of missing pattern here. I just want to see what the hell it is. Response parsing error. I wonder if that's what we're getting. So response parsing error. We'll just do that. I don't think that has a payload, does it? No. Cool. Okay, so we're failing to parse the thing. And I think it's because we're reading from the wrong socket. So we can receive straight from the raw socket, right? But since we have TLS, right, and we feed that socket into the TLS machinery, right? Then we kind of want to have a reader. Okay, this is going to be interesting because we would like to be able to do composable reading pipelines, right? So when you read from the reader, right? The reader could be a socket, so you read straight from that, but it could be wrapped in a TLS, right, reader. And then every time you read a byte, like it's just gonna go through that reader first. So then the readers pull each other, right? So if you have, you know, if you do a receive, right, on the socket, then that just reads from socket. If you do a receive on a TLS socket, then that like reads from TLS, and this internally will read from socket, right? And in that way, you can do more things. Like if you want to receive from like a, I don't know, mapper, right? Or let's say like a gzip, then this reads from gzip, right? Which will read from TLS, which I don't know if that's the right ordering for this specific pipeline, but that's the idea. You would compose these readers, right? And then they will read from each other. And that way, when you need to read some gzip, then it will read the least amount of it needs from its own source, right? And so on and so forth. So I think we're going to need an abstraction like this. And that's exciting because I liked using these abstractions in Rust, right? But I haven't implemented something like this yet. I wonder if it will make sense to use something like seek. And I think we can probably learn from IOStream, this library. Defines generic IOStreams. So OCaml IOStream. Okay, that's excellent. They may be backed by an effect-based scheduler. Let's see how we can use them. Core. So let's see an example first. In buffer, I guess. So we create an in stream. I don't really like this name already. IOStream in. Just call it reader. I think it will be easier for people to be like, oh, we're going to read from somewhere. Subjective, but you know. I do a lot of Jacob's law. Users spend most time, devs spend most of their time on other libraries and languages and frameworks. This means that devs prefer your library to work the same way as all the other libraries they already know. And I know that sucks sometimes because, you know, web development looks everywhere looks the same and so on. But hey, this is one of the big reasons that people can just use a website without needing to be trained on it. Cool link though. I'll just drop it in the chat. I'm also realizing that if I have the chat here, then on stream, right, you'll see the chat twice, right? Like the overlay over there. Oh my God, that's terrible. Chat, come on. Why didn't know what to say anything? I think I'm going to put chat below. Let's see. Okay, that's a slow feedback loop. Come on, update. I am seeing on my phone, right, where the chat ends up. But I think it's so far behind. It's like, I don't know. I don't. Oh no, it's fine. Oh my god. Right. Okay, this is pretty terrible. You don't see it, but this is like the chat is at the end of my screen, right? So if I put it a little further to the right, you'll see a part of it just disappears. That means I can read that, but I can if I have it here. Okay, 3.5 seconds, not so bad. Then my video will cover it, which is fine. I need to find a better problem, like a way to fix this. I don't mind having the overlay chat right on my computer open all the time. This just feels very hacky. Chat, can't believe you didn't say anything. Okay, IO stream. This is good though. Like you can create an input reader from a string. What else can you create a reader from? Buffers, bytes. You can fill the buffer. This I don't understand what. Fill buffer with the in channel. Which is really just an in buffered stream. I never really liked the term buffered. It just it doesn't. It's not. I don't think it's a good metaphor. I would rather have something like bounded and unbounded, right? Which I also don't think is a perfect metaphor. But usually in like a buffer reader, you can say like this is the size of my buffer, right? I want you to read at most this much. And then once it's cleared, then you can read some more, right? Um, okay, so but not gonna lie, Simon stuff, CQ like CQ in Simon Croans. I think it's Croans. Oh, Cranes. I don't know. He's from Washington. I don't know how to pronounce his name, but Simon stuff, top notch, top notch. In fact, if you want to build like multi-core OCaml things, right, that are not like so IO heavy, like you don't need millions of connections, you just need like to crunch numbers, stuff like that. There, he's got a project called Moonpool, and Moonpool is where is it here? This one, freaking amazing. Yeah, this is like excellent for running things that are CPU intensive, like if you need to crunch numbers or things like that. Which makes it think I think this might be a good fit for whatever, like the ECS engine that TJ DeVries was working on, because you probably don't want the overhead of message passing there. I don't know, but yeah, just dropping this in the chat. See, I don't know where the chat is anymore. There you go. 3 monitors. Yeah, I know, but I'm cat sitting here, so this is what I have. I have one screen, right, like here. It's not even like the largest one. It's a 14-inch. I think it's a 14-inch. Yeah, MacBook. Okay. Anyway, so detour there. Moonpool is great. Use Moonpool unless you need like heavy I/O and millions of processes. In that case, use Riot. Okay, I think this will be an interesting thing to look at. What I don't know yet is how it fits into other schedulers, right? Because I don't see any like EIO tests here and so on. I just see like Unix, for example. Default buffer size, right? Nice. Ooh, classes. I wonder if this is needed so that you can override, right? Like to do open recursion on things like read. But I also see this is working a lot with bytes. I think this maybe doesn't have any dependencies, which is pretty good. Yeah, that's great. Okay, so I think we could use this as a base, but we definitely want something that doesn't use classes, because and doesn't. There you go. And we want something that works with I/O, vectorized I/O, right? So like C struct T or a big string AF, that sort of thing. So it's crazy fast. And I think I would prefer the interface to be more around the lines of like you got a reader, right, and then you make like of or make from C struct or reader from reader if you want to compose them, right? Right. So then we would have our like socket reader, right? Socket yield reader from file descriptor, right? And then we'll do our TLS. We'll do our TLS magic here, right? And then we'll do reader, right? From reader. And then and this will be a reader. So we'll do that. So in this case, it's not very convenient to compose them, but you can see how we could do a neat little pipeline saying socket, right? Reader from FD, reader from TLS, reader, gzip, and so on, right? And then you get a final reader here. And this will be the thing that when you do receive on, where the hell's our code? Oh, it's below. Here, instead of passing the raw socket, right, you will pass an instance of this reader type. So that means this API becomes a little higher level, so we're not working with file descriptors anymore, right? But that also means composing things like how to read TLS and gzip and so on out of the socket is just very straightforward. So we'll do net socket receive, right? And I wonder if it will even make sense to do something like reader sync, right? And just pass in a function, right? Essentially, will be something like buffer, like consume the reader, right, into a value. I don't know, how does Rust do this? We want to go into docs.rs reader. No, not a crate. This should be part of standard library. Nice. It can be excessively inefficient to work directly with a read instance. Yeah, I guess we're doing Rust now. Like we're reading Rust. Every call to read on TCP stream results in system call, right? Why did we go to buff reader? I wanted to go to just reader. Didn't we have reader? I guess we don't. Ah, okay. So the buff reader wraps the read instances. Ooh, look at that. Ooh, astronomy. And then comes whiskey in the jar. Okay, so read in here. I think this probably wants to be an interface, right? Does that make sense, chat? Like the problem space that we have here? Because we need to read through the socket that is wrapped in a TLS reader, essentially. And the way that this was done in, not in EIO, but in TLS EIO, mirror left, OCaml TLS. Was using what they call a flow. So when you do a client of flow, you're giving us a flow that I believe needs to be client of flow, bidirectional, two-way. Yeah, a two-way flow, so you can read and write. So I guess EIO's flows are the readers, right? Maybe they're more. Let's have a look at that. We don't need OPAM right now. What's a flow? Byte streams, yeah. Source provides streams, two-way can do both. And then you have buff read here. Fairly efficient non-backtracking parsers. What? That's very specific. Peaking for, okay. We actually want something maybe even lower level than that. So far I'm leaning towards this interface. And I think the nice thing is we can probably make those be agnostic of, right? If it's just an interface, then you would provide like a Riot reader, right? Internally, we would do it. But we would be able to standardize this more broadly. So, hey, here's readers for all sorts of things, instead of having to change the primitive, right, for doing buffered reads, composable buffer reads, right, in the ecosystem. But right now, I don't care about that. We just have one goal in mind, and that is to actually get that example to work. So let's do that. Let's say that we will have in the standard library, right, called lib, because we cannot call it standard lib. We have an IO module. We will add to it. Okay. So we'll have a module type called read, right? And we need some of these things here. Let's just sketch it out. We will need a function for reading things. So vol read, right? And that will take a t, and I guess the t will need to be specified somehow. And we want to read into a buffer, so we will take a buffer, and this is now vectored. Ooh, provide a method. That's interesting. You get this for free if you just implement how to read from bytes. How does it do that magic? I would figure that this and this would be different syscalls. All right, don't matter right now. We'll just go for it, and we want cstruct t array. That's what you will be reading from, and then you will return a read. So this pulls some bytes from the source into the specified buffer, returning how many bytes were read. Does not provide any guarantees about whether it's blocking, waiting for data, but if an object needs to block for a read and cannot, it will typically signal an error value. Okay, that's good, because we have already a type called read, right? That it's either a read or an abort with an error, right? Or a retry. Right, so you open and then you read. And they have this very nice interface, right? Because file implements the read trait. We don't have that, unfortunately. But that doesn't mean we can't make it happen, right? So at least internally, we could have a make reader functor, right? That just takes a base module that implements read, and then we will give you some nice things. So in the file, right? We could just do include, IO make reader, right? Or reader make. And then you tell it what your type is, right? And in this case, it will be T, so non-rec. Or actually, even file. And then if you tell us, what else do we need to know? We just need to know how to read. How does that work? Let's go into a standard FS file. Just take me to file, thank you. I want to see the implementation of read. So this just calls read on the internal 0. So struct file. Okay, inner read buff. That's fine. We have an inner there. FS implementation file. So let's actually go a little bigger here. Will this be included somewhere? Maybe it's here. Fine. GitHub.com rustlang rust fsimp. What's the name of the thing we want to search for? It's called fsimp file. Actually, let's see if it's being alias here. Create sys. Okay, so this is part of the system. Great, cool. So sys, I guess. All creates docsrs sys latest. Are you sure? There's no sys crate? See it internally in the repo at least. Library, standard, source, fs. What? No, this is using the syscrate here. So it has to be somewhere, right? Source. See the compiler. There you go. Standard source is file. And this is just a file descriptor, which my guess is also implements read, but this will happen somewhere else. Implement read. Why is it not here? We just saw it here, right? There we go. So read, and that took the borrow, and then does inner, and then does read. Show more. Okay, so I guess this is it. This is the one. What? No, this is not. What are you doing to me? That is definitely not where we were before. Oh, garbage. Garbage software. All of it. Not that I produce anything better. So we wanted to go into solid fast. I mean, inner is, right? File implementation. What am I missing? It doesn't implement read. I don't see any associated read functions. Okay, there we go. File. I think this is it. Unsafe. Ha! Look at that. Every time you read files in Rust, it's unsafe. And we are calling some C code. All right. Back at C, I guess. So that was that. Nice stream. See you, everybody. I don't want to write more C. But here we would define how to actually read for this kind of type. And it seems that in this case, it's just defined as a read over a file descriptor, right? So it will be something like let read, and then we get a T, and we get a buffer, right? And since we know that T is just a file descriptor, then we will do something like fet, file descriptor read, like that. And in this case, the file descriptor does not implement that. But this would mean we magically get all of these nice functions, and at least the interface to reading a file, right, is preserved. When you compare, like, it's the same interface as like reading from a socket and so on at this low level, which means if we say that this is going to give you back a reader, right, then we can treat every file, right, as a reader as well. You wouldn't have to pass in the module you're using, which is not very nice. Like from, reader from reader, right? or maybe even just file from reader. If the like we can invert the composition so that every module knows how to compose because that's part of the functor, right? And then we do socket. So then you can treat a socket like a file, which is probably a bad idea. Anyway, so just playing around with this right now. Let's see how far we go. So if we implement that, let's say we just implement read, right? Then we want to be able to implement buff reader, right? And this is an actual struct, so module buff reader. Probably something in module like that, buffered. I feel like this is more OCaml than this. And so a buff reader essentially has a reader inside of some type, right? Something like that. Let's see how that looks like. Hello, LSP. IO reader buffered. We can change that. Right. But we want to be able to make that, right? Let make, and you will give us a T. And that will be something like a file or anything really. And right now we'll just save that like that. So if we do make, so if you give me a module that implements read, yeah, then I can wrap that in a buffer. I like that. So let's actually open another file and we're going to test, and we'll go into IO reader tests. Just that. Dune test. IO reader test. Cool. So here we can do open Riot, IO. What? Why don't you like that? Oh, I'm sorry. Did I need to do a full? Yeah, okay. IO this interface is not part of that. God damn it. Right, MLI. Make, and here we can do module IO Riot. Like if I do open Riot, then I don't need to do that. I do not need to do that, but I can do file. Why doesn't this like it? We literally have that IO in here. Okay, so it's happy with that. Cool, so we say make, and if you give me something that implements IO read with that type, and now this one doesn't, right? But it could. So if we did include IO now we can do reader make, right? And in here would be type t is equals to file. Read, and here we'll do something funky, but cool. So if we go to file, this will be here after all that stuff, and we should be able to actually, I think we'll need to put the functor here. I forget how to do functor interfaces, so we'll just generate that. And it did not. Wow, just ignored it. Okay. Let's see if OCaml Genie can generate interfaces. It's probably a bad idea, but generate an interface. What about a functor? Is that the right signature for a functor? I think it's just called functor, right? I am blanking. Chat. How do we do this? How do we expose the functorized an interface that's generated by a functor, right? I guess we just need to do. We can do that, right? So this might be problematic. Because we have an alpha there. Ah, wait. This is a reader. This takes, by definition, a read file. Something we can read from. Nice. See how far we can push that. So the usefulness there of the type is that it allows us to have multiple implementations, right? They have the same read with different types. Problem is that this T will be defined for like read file, right? And if we want to make a write interface, then we'll just use write file. Then we'll end up with these two types. And we don't really want to do that, right? Like write T and read T. It would be best if we just did that. But for buffered to actually be able to take that in, it needs to know what the name of the type is. So we need a type that will be like, oh, this is the type for reads, and that type will need to be exposed. And that makes this kind of suck, right? Because we'll have a lot of noise. Like it doesn't really matter, I don't know, performance-wise, why not? Just have some more types, right? But it will make things look a little funky. Let's see how it would look. Read T. Oh, the Riot MLI. For buffered, it's still expecting a T. Man. Oh, that is not the type for sure. Above C struck the T. Read. That's more like it. So we expect something read T buff, and we get read buff here as well. I'm also getting tired of writing systruct TRA. I might just make a buffer module and call it that. Buffer T would be that, but then you have this one buffer that people or things can rely on. So what's the problem here? Type read T systruct array where Riot MLI 434. Do not see the problem. Oh, there we go. Read T. Not allowed that we need that. Line 14. Cool. So now the test fails. That's okay. But this gives us a buffered module. So if you give me that reader, then that would come back with a buffered file reader. I guess the question is, we want to be able to do something like file, right? File open read. And then we'll do some path like, fixtures. I think we have a test fixture even. Right? We get a file there. And we want to be able to make a reader out of that. Is that how we want to use this API? So I like the way that in Rust they do that. We'll do buff reader new and you just pass in a file. So we can't really do the same, right? Because we don't have traits. That's okay. But what's the closest, or what's an ergonomic API for us to use? We have a file read, we have a module file, right? That implements the reader API. We cannot really put things in IO reader, right? Because file depends on that. But we could make something like file, right? To reader, right? For example. So now that you have a reader, then we can buffer it, right? The reader and then buff reader make. Because you could also operate on that file, like just do read file, right? No, read. Or check stats or all sorts of things. But I guess if we did to reader, then we're constraining down what you actually can do with that. And what I like about that API is that we don't really need to leak this module at all, right? We can just keep that in here internally. Which also means we don't need the read T. We can just do a T there. And then when we do let to reader, right? When we get a T, we just need to pack, right, the reader with the read module itself. So this will be like reader make, right, module read T. Not to be confused with the make functor. Just let me play with this for a second. I think if we get it right, it will be kind of cool because we will package all of that complexity right inside of the libraries. And for the user, it will just be like, oh, I guess types can be, files can be turned into readers, and sockets can be turned into readers and stuff like that. So we won't have that, or yeah, we won't have that, but we'll have a val to reader, right? And then this will be a read file. What? This is not the types we want. I think, yeah, read file's fine. And then we will get IO reader T, right? I don't know yet what the type will be, but there will definitely be a type here for this. Okay, so here we will get a module R that implements read, right? And then we will get a value, like the thing to read, and that'll, I guess, like a target, or really a source. So we can do a type T here. My gut tells me that we'll need an existential here to get rid of the read file type and just say like, now this is just a reader, right? You don't really know what's what anymore. So something like this, right? If you give me, I'm gonna turn this into a nice type. If you give me a T read, right, and a T, then I will give you back a reader, right? So, you with me, chat? Nice. So what I like about this is that we have a reader now, and we have hidden entirely, right, the source of that reader, which means we can pack many readers for different sources together, and yet they all have the module that they would use for reading, and that's also a standard interface, right, that we can use. So pretty happy about that so far. Do wait. So the beautiful thing is that when we make a buffered thing now, we don't really need to care where it comes from. Which is excellent. So T. I don't know what this is going to be, but it's probably going to be like a buffer inside, right? Buffer, and that will be a C struct T array or something. Buffer size. And we'll have like a default buffer size, like I don't know, 400. 4 kilobytes. So buffer size is just going to be the default buffer size, and then we'll get some T, right? And then we'll put together our buffer, which will be, I don't know yet how to do this. Might just be a single struct, might be more. For now, I just want to make it compile, right? We can do size here. I think that's okay. No, what the hell did I do? Okay, so the control I actually does something here that I don't like. I would probably end up changing that. What am I doing? I become one of these people that have like a long terminal. Long terminals are useless. You want your terminals to be tall. Wow. What's happening here? Cool. Gonna open the test in a different file. Cool. Okay, so we have IO on the top, and then we have file at the bottom. Cool. What do we do with the T, right? I guess this will be our reader. Let's see the type of that reader. I'm gonna guess that it's going to be a reader file, so this is gonna fail. Yep, it's a reader file. That's kind of nice though. So the buffered one is just like, what are you reading from? But unfortunately, we don't have a good way of keeping track of that. I mean, we could make the reader, right, IO reader parameterized by that. But we said that we didn't want that. Why did we say that? Let's see. Okay, that's interesting. So we go from a file, right, to, I think I'm gonna get rid of all those aliases. They are convenient though. So we go from a file that we can read on, right, to a reader of a file that we can read on, to a buffer reader, right, of a file we can read on. So far, so good. The type things are working nice, so we can just pack things together. Now the question is the composition aspect, because if we nail the composition part, then this is going to be amazing, right? It's a very nice API for building, streaming buffered and unbuffered data things. Okay, so like Rust, let's actually just ask the GPT. Yo, GPT, can you give me an example of Rust code doing streaming buffered read of a file and un-gzipping it? Let's see. I mean, come on. Look at that. Right? That's the API one we want. So, I mean, not the same, but you know what I mean. Let's see. What happens if we try to type check that? And if we do buff reader, just to have it complain. Look at that. So, chat. Let's do a gzip decoder, right? We have some type T, and right now we're just gonna do like a unit. We don't care about this, right? And there will be a read module in here, just like we have for file, right? Like that. But instead of turning like one of this into a reader, which we can't, right? Because this is the thing that does the reading. It's not a source, right? We will have something like of reader, right? And we will get a reader here. I guess we want to do reader. If we have a reader, we need a source, right? How will this work? Unzip. Right. How do we configure the mode? If this was a buffer T, then that would compile, and we'll get maybe we want to be abstract over that type. So if we want to decode, and then we want to do something like decrypt, right? Encrypt. So this will be the goal, right? What? Oh, unzip, like that. It's like, okay, we have a file, we're buffer reading it, we're gzipping it, we're encrypting it, right? Sorry, I lost the chat here, but what do y'all think? How does this look? The hell's the chat? Oh crap, I missed a ton of messages. All right, let me just get back to that. Ryan, so when I was in high school, there were a few groups. Right, you like Foo Fighters? Or are you more of a Soundgarden person? Love a good functor? Yes, me too. Hey Mandex, how's it going? Good to see you. Hey Hans. Cursive and bold? Come on, seriously? Thanks, Dylan. I realized you left already, but thank you. Thank you for hanging out. And I hope you enjoy the day with your family too. Family functions, right? Not family objects, family functions. Hey, Kiev. No, 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 no. Come on, Privan. It was no fault. Look at this. Look at this. This is Rust right here. We're looking and learning from how Rust modeled, right? Buffer reader streams of data, right? To try to build an API that looks kind of like that. So in here, we say like we have a file, right? We're going to turn a file into a reader, right? And then we can grab the reader and make it a buffer reader. So we go from file to reader to buffer reader, right? And then we can stream that into a gzip decoder, which we can stream into an uncryptor, right? So we're building this pipeline because there's a good reason for this. Because in Blink, I'm actually going to close this one over here. I don't need this anymore. I was trying to figure out why rendering a lot of emojis in Minty was breaking. Community notes, seriously. Get out of here. Because in Blink, right, we connect now through TLS, right? And we get a socket here. And when that happens, that's all fun and games, right? Until we need to read from that socket through, right, TLS. And when you want to do that, then right now it's like, sure, TLS has inside the original socket and it has a buffer, right? But then either you drive it manually yourself, right, to do the things it needs to do, or you try to read from the socket yourself. And if you can't, then just drive. I mean, you have to drive TLS, and that sucks. So we want an abstraction that would make it nice to see, like, okay, here's a socket, right? We'll do a reader. Actually, we need more than that. We need a... we'll see what we call that. But at least for receiving purposes, right here. We will grab the socket and say, like, net socket to reader sock, right? And then let TLS sock, and that's going to be TLS, I think that's the name of the module, of reader, right, sock, and then receive will actually take a reader stream instead of an actual socket. So when you call receive, it will pull this thing, which will pull this thing. And then the data goes through these different layers. I never really got into bands like NoFX or Pennywise. I guess, yeah, I definitely think a lot of the reason why we listen to some things is the social circles we inhabit, right? Which it doesn't mean that because your circle listens to something, you end up listening to that. Sometimes it's a reaction to it, right? Like, oh, I am surrounded by people that listen to this thing, so I will listen to something else. But yeah, Privan, this is the closest we can get, right, to the type error you see here in the playground, where it says, oh, gzip decoder new reader. That is not the thing that you said. Is actually, right, a gz decoder for a buff reader of a file, which is what we have here. Plus minus. We have a lot of module namespace in here. We can probably flatten that, make it smaller, easier to read. But what I kind of like about this version, now that the types are here, is that This maps very nicely with the pipeline intuition, right? Or metaphor, where I'm gonna read from a file, I'm gonna put it through a buffer, I'm gonna decode it and encrypt it, and then what I get is the encrypted, unzipped, right, contents of the file. Yeah, again, these are just to sample things, but this will be the pattern, right? So if you wanted to do an off reader, we'll see. We might actually be able to enforce this interface so that the types are all nice. I don't know. We'll see. What I know now is that I have the types I care about, right? So I'll remove that. And now we'll see how we can implement this thing to do something, to actually read that. Breath fun. What I'm wondering is if a buffered read is that also just a read? Maybe that doesn't matter as much. Okay, so what can we do with a buffer? Okay, so we do have something called above reader, right? Or above read. And it looks pretty damn close. I mean, it is a read, so it includes. What? I wish it didn't look so terrible. It looks very ominous. Okay, we're gonna tweet that. Efficient, composable, type safe, read, write streams for Riot. Rocket. What do you think of this interface? Is it OCaml neat? Boom. Amen. Nope. Sorry, that was the wrong link. This is the link. What the fuck? I swear that I copy pasted that. There you go. Then it was all like bam bam bam. Okay. So if that's the interface we're gonna have, which I adore, we need to figure out how to consume from it. So we have read to end. Oh yeah, this didn't work very well, but don't matter. Right, so in this case, this of reader, right, is just turning this into this struct, and that struct doesn't implement anything. So we'll have to figure out how to make that include the methods that we expect of, right? Like here, like read to end, for example, right? That's something that I would expect this thing to have because we were able to create it from a reader, right? So just to see how that looks like, if we look for Flake 2 for Rust, then we have some sources and GZ decoder, that's what we want. It's in GC, right? Cool. And then I guess this implements read. Yeah, read and buffer read actually. Okay, implements read as long as the thing inside is buffer read. We won't be able to do all of this trade magic, but we should be able to come up with a pretty nice interface for it. Cool. So I'll leave those for, actually we can get, I'm going to comment them out for now. Let's look at the interface for buffered. Where are we? buffered read here. No, this is read. I want buff reader, right? Here. Crazy, I'm stone cold crazy, you know. So we want essentially IO reader, right? Read line. We can do that. Does read line come from here? Yeah. I guess we could also just try something smaller, like size will be like 8. So 8 bytes, right? Make a reader of 8 bytes. And we want to just fill buffer. And this will be reader, right? But we also need a buffer. No, I guess this will actually just fill the internal buffer if we have one. So that would have to be a method inside of buffered. So you fill that buffer. I'm curious, like read exact. Oh, okay. Read exact, that's the thing. And you give it a buffer. Okay, we can start with read. And read will actually fill the internal buffer, so it will go up to 8. I think. Pull some bytes from the source, eat the specified buffer. This comes from buff reader. No, I want to read up to. I guess the size here doesn't matter, right? Like if you say I want to, let's say we have a buff here, buff, and I know we have a buffer type. Don't like that. Okay, C struct create, right? If we say I want to get like 16 bytes here, I'm gonna say read, right, from this reader into this buffer. Then this will make 2 reads. The first read will read up to 8 bytes, right? That's as much as it can feed in its internal buffer, right? Yeah. And if we do 2 bytes here, right, then this will still read 8. But it will always read up to buffer, right? Up to 16 tops, right? It might need to do multiple reads depending on this buffer size, right? So if this was 16 or 32, then we would be able to read more than we can fit into this buffer. So we would just read 16, right? But if we read 8 here, then that would mean that the capacity of this buffer is smaller than, I like capacity much better than size. But then we have to do more reads. We will fill up to 8, right? And then we'll keep that in memory and then flush that into the buffer that you want, right? Like the C struct and so on. Oh, there's a link on stream somewhere. GPT, OCaml, Genie. I think this is it. It's public, by the way. It's like about. Yeah, it's completely public. No worries. I wanted to get a domain like camel.ai, but this is taken, and ocaml.ai was like really expensive. €2 for 84 euros. I mean, I think I need to buy 2 years at a time, so this would be 170 or something like that. Skip everything. Yeah, 177. A little less if I can remove the privacy and stuff. That's fine. So 170. Should we buy this domain and put the OCaml Genie custom GPT behind it? Donations welcome. Money. Thinking. All right, chat. Music requests. I feel like listening to something else now. What do you have in mind? If not, we're gonna finish listening to Reload. Or maybe we even will do that first. Yeah, I'm starting to think that buffer will actually need to be a read. So we will do something like this. And then you'll do buffered. Capacity. Right? And then you'll pass in a T. Overkill. Maybe not exactly like that. So this way, buffered and unbuffered, they have the same interface. So if you need buffering, you can just call buffered, and it will just make whatever reader you have up to that point buffered, right? But it doesn't change the rest of the interface. I don't know if that's a good or a bad idea yet. But it's definitely an idea. For a damaged case. Right. So we can now implement things like read, right? And if you do read and give me a T, it will be like reader module R, right? I think this will be rid of, yeah. Fine. Got a feeling that the pack module will need an extension, so. All right, that type checks. Perfect. So the idea is that here we have a module that's an R, and that is a read, right? A read, one of those. So we can call read on the source. And pass it a buff. Bam, now. also I kind of need all of these modules, right, to always return an IO reader T. I need it exposed as well. But if I do this, right, I feel like they're gonna flatten out the type. So file, this should be a reader, but it just says encrypt there. Then we get a buffered one, and then it's just still buffered, but it doesn't really reflect what's happening. Don't like that. Okay, we're gonna go back to the old API we had. Wait, what was the problem here? When we have this API, right, without the thing, and when we didn't have this stuff here, what was the issue? If we go back a little bit, we got a source T buffer, that was fine. Right, we had make. Right, instead it was like buffered and then make. And then we went from, actually let me just unwind. Cool. Even further back, maybe. Yeah, okay, so I'll copy some of these steps. This I want, but I also want to go back to this. Oh, okay, so up to there and then buffered make. So now we go from a file to a reader, file, reader, buffer, reader, right? And then a gzip decoder and then an encrypt. But at the end, we need a read function. So we need to make sure that either we call encrypt, right, read, which would implement, like we just need to pull the first one, right? And then the problem is that we need to know who the hell is this gzipper decoder, and we don't. So maybe, right, all of this are all fine, right, like that, but internally they're really just more readers. Now the problem there is going to be that now that we want an IO reader T, right, get rid of that for a second. That ain't going to work because we have a buffer T instead of the IO reader T. Internally though, there is a reader here, right? So maybe when you do make, we actually want to end up creating a reader out of this thing. So at that point, we don't know anymore what our source is here. But we can specify that because the source is going to be in the signature. I think this could work. My gut tells me it's a little nicer than what we were trying before, just slightly similar though. So we do a buff read here, right? And that will be a make. And I really want to rename that to make read, but so we have a type T. It's going to be T. And our function is going to be there, right? So read, it's going to be read. So it's going to be non-recursive. Oh, non-rec. Cool. So now of reader, let's see, make of reader. Let's try this. I think we don't need much here. We need a type T for sure. Actually, do we even need a type T there? Let's see. Let's have that for a second. We want an of reader, right? Which will have capacity of int. And then we will get a source reader, right? And then we will get a source reader out that will be buffered, right? We'll see what the difference is. A resource gives you a T. Right. So this doesn't really return anything. It returns a T, which means we go from a reader of a file, right, to nothing of reader. Yeah, this just drops all the stuff. And really, we want to swap out the reader itself, not the contents, not the source, right? So that's not very nice. We do want this. Okay, so let's start with that. Maybe we do have a packed, right? And that's like a buffer of source D that is packed. Bad things seen. Like now that returns what we expect it to return. Does it? Okay, so let's go with this for a second, right? For our reads, we will have a regular type, right, and a buffer. or actually we don't even care about that, but this type over here should not work, because right now this should be a T, right? This is the actual buffering reading that we will do, and we know the source and everything, right? But here we don't, because this read has a packed read, right? So we will have something more like type source, right? Actually, not even that. Packed, and then we'll take a buffer of a C struct T, right? And then we'll return a read from that. Hey, meant to me, I just saw your message. Is there a good guide? What I normally do, right, is that if I'm on a repo, let's say here I'm on Riot, right? I do opam pin, right? And you can put the name of the package and the version, and then here goes the source, right? And this could be dot for the local folder, but I think you can also put a URL here. I don't know. You could try that though. Either clone the thing and then do a pump pin with dots, right? Or try putting the URL to GitHub here. And so on. Let me know if it works. Hello, S. Pedro. How's it going? We are pushing the OCaml module system to try to build something like the Rust buffer streams, right, that are typed. So you get a file and you know that it's going to be wrapped in a buffer reader, that is going to be decoded, so that when you read from the decoder, it goes decoder, buffer, file. And we need this to be able to read from a socket that is like wrapped in a TLS decoder. Really? That's hmm. It's me. So we're not using it to pack things, but we are using it to unpack stuff, right? What's the problem? A bunch of unused stuff that I don't care about. Oh man, why does he do that? This also feels like the wrong default. Like I'm developing right now, right? Let me have unused fields and crap like that, but make those errors during like the release build, right? Right now, I don't want to focus on this, but maybe we need to start creating some Doom profiles. All right, let's try our camel genie. Make me. I need to configure Dune so that on development builds will disable unused constructor and unused field warnings. But in release mode, it does not ignore them. All right, let's give that a shot. Nice. This is excellent. This should be the default. Least amount of warnings possible, right? No, Leia. It's not the time. Leia. Go away. I have a cat. In case you're wondering why I'm looking at a spray here. It's not mine. I'm cat sitting for a friend. And I've been told to use this spray to tell the cat Leia where not to go. For example, 1 second. There you go. She loves just like hanging around here in the computer and so on. Anyway, so I was saying, I think probably most warnings, right, we will want to get rid of. Right now, I think maybe 39, 37 during development. So I just want to be able to focus on the type, right, part, the tests. And then in release, I can just crank it up and be like, all right, just, release. Show me how I'm not building all these things. What? Release does... Why is this the opposite? Flags, standard. Soon. We're doing the IO reading right now. Once we have that, then we'll be able to finish the TLS reading. These composable streams are good though. See, this makes perfect sense to me. In release mode, all the warnings, all of them, absolutely all of them. During development, maybe not all of them all the time. You'd be surprised, Ryan, like so much of what I learned in Erlang and Elixir transfers well here. Like what I'm doing right now is like crazy low level. This would be like a mix of NIFs and stuff like that, right? Like it's not the kind of programming that we do in OCaml with Riot, right? At all. Like if you look at Phoenix, right? It's pretty high level code. Like you have to go through Phoenix, Unplug, and Bandit, right? And then you go into Thousand Island. And at that level, it's like, oh, okay. You're actually calling GenTCP and doing things with the socket, right? But you don't do those things all the way in Phoenix land, right? You work with a connection object. Now, what did I just say? Leia. Não pode. Pápala. Sai daqui. "600 seconds of OCaml." Dude, I gave you 14 hours, 15 hours of OCaml yesterday. What you talking? 600 seconds of OCaml. You know how many seconds there are in an hour in 15 hours? 24. No, 60 by 60. I gave you 54,000 seconds of OCaml. Oh, Sabine, you're here. Cool. I have something to complain publicly about. So this is the default behavior of Dune, right? It's like, oh, you have a bunch of fields you're not using, and like, I don't care. I am developing right now. I will add shit that maybe will be removed. I don't want my code base to be super tight, right, on every loop, right, while developing. I need it to be looser. I have a buffer here, right? I'm not using that. That's okay. It's there for later, maybe, right? And the best part is that when you build in release mode, it just goes by. No warnings whatsoever. How is this the default? Like, it just feels exactly backwards. Like, development should be as loose as possible, right? And then when you go to release, you get all of the warnings. So this is the amp I'm using now, where during development, I just get the type errors, the things that I actually need to fix, right? And on release, it's like, okay, Leandro, buckle up, right? Here's all the stuff that is warnings and problems that you need to look at and fix at some point. I know, what the fuck, right? It's release, but it could be prod, right? I think release is just it's an okay name. I like it. Like Cargo does the same, right? You get debug builds and release builds. So yeah, this is my recommended env config right now. Also, this, like MDX, just enable it for everything, please. By default. Oh, yeah. I think the debug builds are usually pretty fast as well, both in compilation time and execution time. So 450, what's the problem here? Of reader is returning one of those. What are you complaining about? Oh, source? Is that what we want? Yeah. Cool. So we have a reader, we have a buffer reader, and now, okay, yeah, we want to keep that as a reader. Cool. So now we have the T, right, which is our reader itself. What? The fuck is this? Come on, LSP, don't be... Are you serious? What's happening? There you go. Cool. So we have our T, and we want to pack it, right? So we can implement all of our buffer reading logic, right? But still be able to use it as a regular buffer, regular reader. Now that it's packed, we can do of read source here, and we'll do module buff read, right, and pack. Cool. And this will be great. We don't even need the time anymore, right? This will just be a reader. Born into attitude. File, file, reader. Come on. Why does he do that? I want to. I wonder if I need to implement the module inline. For it to capture the right type. So instead of using buffer there, maybe I can do some weird things like if you give me a capacity, that's good, right? So capacity int, and if you give me a reader of source reader, then I will give you a source reader. No, god damn it, non-rec. So my impression is that the LSP works brilliantly until you start doing heavy module things. And then it just goes to shit. Oh yeah. Reader, right? File. And then we get that's a file. This is a file reader, and this is a buffered file reader. A file buffer reader. Okay, so far so good. This is a file buffered encrypt. We're not using that right now, so it's okay. And then we need to do read, and then this will just work. Magic. So the important thing is that we still have a reader at the end, right? So it will work with our reader, because our read here, it really expects you to give in a reader, right? Do we even need that T? If I remove that, something breaks. Just to reader. Gonna get rid of that for a second. Okay, so file, reader, buffer reader, and then we call that unbound value reader read. That's fine. We haven't exposed it yet. So now we can expose it, right? We have in the reader, and one of the common operations that readers will do is to read, right? And I think we can just do source like that there. And we should get a read back. So maybe if we do that, we can destruct. No, that's not what I want to destruct the entire expression. There you go. That's also something tricky. Usually I have less issues destructuring when I'm on the left side of the expression than I want to do that on. Like if I do buff, right? Here it's just going to work both ways. But here, when I have a function call, with the cursor on the right, if I destruct, it just destructed the buffer. The first thing to the left, which is weird. Cool. So we want to just know how much we read, right? And in this case, we want to abort or do some other things. So we have a little test here with some login stuff that we can borrow. So this is for the good case, and for the bad case, I guess we can do that right now. So IO reader test. If we read exactly 16 bytes, right? Anything else that we read, we will consider that an error. When I think we can also just save this. In a result, right? Or an operation, and then we will get a string out of the cstruct to string. Offset is going to be 0, length is going to be 16, and then we'll put in the buffer. So I want to make sure that when the string, right, equals, and I forget what that file is, ioreadb txt, hello world, okay. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 bytes. So let's actually read 11 bytes. Unexpected read, unexpected input, and we pass in the string and the number of bytes. Something went wrong, read, we're going to put whatever we have there, and that bytes will be n. Format, builds, woo, it builds. So read is not going to do anything right now. Yeah, I'm running Dune on watch mode all the time. So that compiled, which is excellent. If we test, I think maybe some tests will run. What? Unhandled effect with of course. God damn it. Riot run. Oh duh. Dummy me. There you go. Command X to code 1. So if we actually want the logger, then we'll need to have a little more like this. The beginning. Cool. So we read garbage. But this is these type checks, and I think as far as interfaces go, it's not the worst. It's pretty nice to be able to grab some source, right, and turn it into a reader, and then use the reader interface in that. We'll see how we can replicate that reader interface for other things, like maybe it makes sense for the TLS module to have functions like read and stuff because it is a reader once we make it a reader. Maybe we just need to say, hey, to reader. So you grab it, so like, wrap as reader or something. So then it goes through the TLS module, but it's still just a reader. So you use the reader module for reading things. We will see. This is the problems we have and the questions that arise, right, when we don't have traits or type classes. She's fine. She's fine. Christ. Cool. So I think this is it. This is everything we need, right? We read just to make this more uniform. Or, I don't know. We'll see how that changes. The interesting thing is that the buffer read right now is just saying retry, right? It doesn't actually try to do any reading. But what if we made it do something, right? And now we can go back to Rust and see, like, how does buffer reader work in Rust? Let's see. Am I gonna get rickrolled? 300 seconds of Rust. All right, stream. I know this guy. Oh, okay. We can make this. Ooh, Vim. Nice. Yeah, we can make this. Oh, let's see how that fundraising went. Oh, we're gonna get a donation. All right, doing that right now. On it. Philippe. People. Mama, they trying to break me. I was of the type. Whoa, no way. We got a donation for the domain. This is serious, folks. It's starting to get real. Okay, I'm gonna get the history. Damn. Okay, that's good. That's pretty good. Thanks. Let's go to Felipe's profile here. Shout out, big shout out to Felipe for the donation. Amazing engineer, all around. Fun guy to follow on the Twitterverse. From Brazil. Mano, muito obrigado. Yes, go follow them. Let's see the rest. Cutie. Good clarification here. Yeah. Less than that. I know, right? What? Okay, we have the confirmation there. Types of getting elixir. All right, folks. We are at. I'm a match that for in a sec. We are at year one. Just need. How much was the price? I forget. 168 minus 80. Yep, just need about $80. That was cool to see happen. What the hell were we doing? I completely lost track of this. All right, yeah. Dropping that in the chat, folks. When did we go to Van Halen? Ooh, Keith, it's been a while. I remember the day that we met. We were gonna look at how Rust implements buff reader. That's what we were trying to do. And then we have buffer, right? Wait, what do you mean? There should be a thing called buffer, right? And it's in the module buffer, so we should be able to find it. Struct buffer. Proc map macro. I don't think this is it though, but library, core, standard, right? Source, buffer. Cool. So they have a buffer here. We don't need that. We have cstruct for that. Bing, bing, dun, dun. But at least we have it there. Cool. Sounds good. This is all internal anyways, so no worries. So buffer, create capacity. Create, and then we do capacity. I don't even think we'll need this. Another thing I don't care about, 62. So now we have the buffer there, and we can do things. So I think everywhere where I have a C struct, I'm gonna actually ask for a buffer T. Kristen. Ah, cool. So line 34, we have some issues here. Line 21. Okay, sorry. In file ML, right? Right. Because now we have that one, and we actually need IO buffer. I forgot that all the things were using this. Are they? I guess single read. So Riot MLI 447 read. Just take a buffer. There we go. I expect everything else to just work. All the tests passed, perfect, just one error. Great. Close everything. We have way too many things open. And we're gonna do IO reader test. And we are gonna implement a toString, so we can just call that. This makes the test a little cleaner. Buffer vol toString t string. That will be t. Okay, cool. So now that we have that, it's gonna clean buffer read. I can just call that read. We can do exec here, test IO reader. X. Cool. And we want a buffer reader. So the hell's that? Buffer reader read. Cool. So if the position is equals to field and the length is bigger than the capacity, if we don't have any buffer data and we're doing a massive read, bypass your internal buffer entirely. Interesting. If t buffer position, I guess we need to keep track of where we are in the buffer to be able to do that reading, right? position, right? What is field in buffer here? Each call to field buff sets field to indicate how many bytes at the start of buff are initialized. Okay, so field is the amount of bytes, right? Mm. No, I think this will be mandatory. If you're giving us a C struct, we want to know exactly how many things are in there. You pull the trigger of mine. So when we do weak capacity, that's fine. I think none of the external APIs have changed, right? Oh, right. Of string, and then field, it's going to be the length. So that's how much stuff we have there. What's the problem? Ball buff read. Oh, this is the problem. Okay. Retry, that's your type check, right? Yeah. Perfect. So we want to do, if the buffer position, right? Going back here, is the same as field, right? So T buffer field. Actually, maybe we don't care about that right now. Maybe, I don't know. And this buffer. So buffer length is bigger than the capacity. So T buffer capacity. Then we want to discard our own buffer. Damn. Discard buffer. And we want to return an inner read. Oh, inner is this one. Okay. Right. That makes sense. Maybe we want to call that inner as well. T inner, right? And we'll do read into the buffer. So if, right? And I think this is pretty much check flag buffer is full. Else, if it's not full, right, and there is room for us to put things in there, then we actually want to fill the buffer. So we can do so what does this do? Self field buff So we want to be able to read from. Sorry, I got distracted trying to set up the phone again because it suspended. All right, let's just do the if it's full. One thing at a time. So discard buffer. What is this? Buff reader. And then we go self.buff. So a lot of this stuff is implemented. I can remove this, close that, close this. Here. Position is going to be 0. Okay, so we will get some sort of reminder, right, from a call to field buffer, and we need to see where the hell that goes, right? But then we want to my guess is that reminder will be us in some shape or form. I don't know because we already have a borrow here mutable, so we wouldn't be able to. Maybe it returns the same mutable borrow after updating, right? Something like that. So let's look at that. So okay, this just goes into the internal buffer, right? So it's something like buffer fill buff, right? And then we're pushing that into the inner buffer, right? So this will be the inner reader, actually. So T buffer, right? And we want it to fill T inner. And we'll see what that means. Because that function definitely exists here, right? Here you go. Fill buffer. And we get anything that implements read. So we cannot do that, right? But let's see what this is actually doing, because we might be able to replicate that behavior in some way. It calls this function. So it's just copying data, right? What? No, wait. It's not copying the data. It's telling us, it's giving us a slice between, what? Get unchecked for the buffer. It's an internal buffer even here, yeah. That should be a slice, right? So here, slice, cool. And we have a range here from self position, like where we currently are, up until where we're filled. I have to squint here and just look without one eye. There's so many tiny little dots, like, that's better. So this gives us back a slice we get a slice back, right? Of the buffer. So we can't really do that, right? But we could, we want something that we can write into. Because we have the buffer, we want to fill in our buffer reading from there. So with that reader, okay, if the position is bigger than filled, that means that there's room. There's room for us to read more things into the buffer. Okay. Cool. So field buffer needs to take something, definitely not a reader, right? But something that will put data in there. Like so far, it's all nice types and games, but we're not really doing much, right? Here's where we actually have to do crap. And here's where maybe our abstraction will just fall apart. Okay, so let's go to the buffer, and we'll do a fill, right? And we'll get a T, and we actually will need some data, right? And here's where we'll check if the position, right, is bigger or equals than the field. That means there is room, right, for us to do something and read. I don't get why this is returning a slice, a readable slice though, but right. So we know that up to T field is safe for us to read, right? So assuming that we have data here and this data is like a C struct, then we should be able to see the position. Why is the position reset 0 here? And field is going to be set to the length of that C struct. Which is the buffer that we're going to read into. From data, and the offset is going to be 0, and the source is going to be t.inert, right? And the offset is going to be 0, and the length is going to be field. So if we do that, then that fills that buffer, right, with some data. So you say, I have this data string or whatever, right? I'm just going to fill it by copying stuff into that. I think this is the same of what we're trying to do here, but let's see. Let's go back, right? Because when we fill it, we get a remainder back. And this is actually bytes. And we're calling read again. I don't know what this rem is here. Because it seems like it's coming from the buffer itself, right? Here. Like just grabbing the buffer and doing a get unchecked on it, right? Can add some here. So position the current. But this is returning something here. Then we call bytes on that and we do read. And then we pass in buff. I'm not sure I understand this. Then we go consume. What does consume do? Calls the buffer and calls consuming the buffer, which so updates the position to be the minimum of the position and some amount. Okay, so that amount some offset here, right? How do we come up with a value? That's going to be the big question here. And then after that, what do? We just return that number, that offset. Okay. So here there's something we need to figure out, which I think maybe this is part of the fact that they have a readable implementation, right? Oh wait, this is in read. It's not here. So it's more like that. So when we call fill, we actually get the offset, or we should. The hell? Like that? Come on. So fill here will grab the data out of this thing, the inner. Actually, the other way around, right? We want to read into the inner. I'm confused. It's a little puzzling right now. Yeah, we definitely want to get an offset from calling field buffer, right? Which is not documented. Let's see. Okay, so it seems like if we create a buffer, oh, this returns a buffer. When we do field, you grab a reader, you say field buffer, then you get a buffer back. But that's happening on the reader. That makes more sense. Because we can implement that, right? If we had to do this in the buffer, then we're kind of screwed. Because the buffer doesn't know anything about readers. It's just very low level as a primitive. So here, we usually get the reader first, right? And we don't get much else. So the reader, the field buffer should create a new buffer with things. Okay, I'm gonna go with that understanding right now, and we'll see where it breaks. But this is where we're actually doing things, so it's fun. We will have a signature kind of like this, field buff, right? Except that here we'll just we'll get a buffer. So our R is a reader, right? And I guess there's also a reader implemented for this. Right. If you grab a reader and you fill a buffer, then you should know how much. No, you don't yet know how much to read, but you know how much you've read. That's the buffer size. Oh, okay, that makes sense. So if you call read and we're not full, then we just like try to fill the buffer, right? And then we move the offset of the buffer with consume. So eventually, a call to read will find a full buffer, right? And I wouldn't be surprised if this. I guess we don't have to recurse here. Somewhere in here, I think it will be a good idea to put a yield, or maybe even here at the read level there. But maybe we'll be okay because we have to go through the lower read v and write b anyways. But essentially, you call read once, and he's like, "Oh, we the buffer is not full, so." Um, right, the buffer is not full, and we also are expected to fill a larger buffer than we currently have. Okay, I thought I understood this, but now I maybe don't. I thought that it would just check if it's full. If it is full, then we'd actually execute the read, right, from the inner buffer into the outer buffer. Like maybe this destination here. Mm. If the buffer is full, right, and the outer buffer is bigger than buffer length, the inner buffer, like no, our internal buffer, right? And I forget if that's the condition that we had. So pos equals, and I think that'll be here. Here. Right, the outer buffer is that one, right? Let's go above here. So the internal buffer is debuf, and the outer buffer is called add. If the length of the outer buffer is bigger than our internal buffer capacity, what does that mean? So we're trying to fill a buffer bigger than we can hold, so we'll need to do more reads. So if it's bigger when we're full, then that means we can drop what we're doing, and what? Why would we do that? All right, folks, we'll do a tiny break here. I'm gonna grab a bite. No, we just got raided. Oh my god. Party of 34. Okay, so no break. We'll stay for another bit. Hey, folks, how's it going? Hey, Metami. Thanks for the raid. I'm gonna do a shout out to you. You tried a Minty. Oh, nice. Did it work? Shout out to Meta Me. Nice. Happy did. Happy did. There's a lot of like optimization stuff that can be done, but I think the API is kind of nice there as it is. We'll see how it evolves. Right, yeah, I understand. I think like the packaging and installing things still needs work. I know there's work happening right now, but like it is what it is right now. Like OCaml is still kind of a pain in the ass to work with. It will get better though. Nice of you to stick around. Thank you. Yeah. So we're actually working on Riot right now. We were um, we were making um, an HTTP client for Riot, right? Something that would be nice and easy to use in a program with. Let's open a browser here. In a program that uses this scheduler for OCaml multicore. The idea is that this algebraic effect scheduler, right, will let you create programs in OCaml like you do them on Erlang or Elixir, right? So you spawn processes and then send messages and receive them, and it is all like automatically scheduled on all of the cores, right? So you don't have to think about like, oh well, I'm gonna put this memory here and I'm gonna synchronize these threads and stuff like that. You just go like, hey Riot, I need 1,000 or 1,000,000 processes, right? And then Riot goes like, all right, I'll take care of it. I'll figure out how to schedule them in different cores and so on. So I started building this maybe a couple of months ago, actually, 3 months ago, according to OCaml format. And it's running nicely so far, right? It lets you do things like supervisors, and we also have a little bit of a generic server that someone is actually helping finish up, drafting more things. Shout out to Dan Dennis for the work. Yeah, so naturally, if we have a scheduler like this, right, and because of how algebraic effect schedulers work, we need to implement some things on top, right, to be able to do nice work with it, like high level work. One of these things is Minty, right? Which you just saw on stream. So very, very happy that you liked it and it was good. PR's work home does a couple of issues here that are, I think, good first issues to get into, especially the component mapping, right? We are learning a lot from Bubbles in the Go ecosystem, right? They have tons of different tiny components that we definitely want to have, like, copy over. So if you want to work on some of these components, that's like awesome. Just PRs are very welcome there. And then other things like mapping more UTF-8 events. Metami, how was your experience like essentially matching for keys, right? How do you find that? Thank you, the Alta 4 stream, for the follow. Well, I guess Metami is gone. It's all right. For the rest of you in the stream, so we were building this, and we also started building Blink, which is an HTTP client for Riot. And it's inspired by Elixir's Mint, in case you've worked with Elixir before. So you sort of get a connection and then make a request, and then you can stream on that connection, and you get like little chunks of the request until it's done, which means very large requests you can actually process in increments, right? Stream in a stream fashion, instead of having to wait until that that entire thing is sort of read for you. And this was working fine until we added the TLS support to be able to fetch OCaml.org, the website, right? Not because of the website, but because of the TLS story. Like, oops. Which takes us to what we're currently doing, right? And in Blink, at some point, when you connect, we open a socket, and we try to read like data from that socket. But to support HTTPS, we need to do TLS, Transport Level Security. I think that's the name. So we wrote a module for dealing with that uses some libraries like X509 in the ecosystem. A lot of really, really strong work here by the people behind Mirage. The problem is that once you do that, you end up with two sockets, right? One of them is the raw socket, and the other one is like a TLS socket, quotes, which is just a raw socket inside here. But what we really want to be able to happen is to say, I open the socket, right? And then I sort of create a TLS wrapper or reader around that socket, right? And then I can just read, right, from TLS. And that actually will read from the socket if it needs to. But in the middle, like, decode TLS stuff, right? So we're building this sort of pipeline. You can imagine if we also had other things like, for example, unzipping or gzipping, right? You will want this thing to like unzip, right? So you build this pipeline, like read from the socket, decode stuff, right? Unzip it, and then give it to the user, like data. So we're building that abstraction inside of Riot. We're using Rust as an inspiration for how to build these buffer readers. So in this example, we have a file that we open for reading, right? And then we turn that file into a reader. So you see here the type says, this is a file reader, right? Maybe that's a little clearer. But we don't want to read the entire file at once. We want it to be buffered. So we will create a buffer reader. So this becomes a file buffer reader, right? And if we wanted to do more things with this, right? Like, for example, decode it, and because, I don't know, it's on base 64 or whatever, right? And then you need to like unzip it because the base 64 is zipped or whatever, or decrypt, right? Then you can just create a chain of all these operations, right? And then later on, when you say, oh, read from this thing, then it goes, okay, I'm going to try to decrypt, right? And then this calls unzip and says, read a little bit, right? And then unzip goes, oh, I need to actually, get some data. So it will call the decode from before, right? So we have this little chain of things happening backwards. So you want to decrypt, you read unzip. You want to unzip, you read decode. You want to decode, you actually read from the buffer, right? If you want to read into the buffer, then you actually need to read into the file. And then the data flows in the other direction, from the file, through the buffer, through the decoder, through the unzipping, through the decryption, and then you get whatever you wanted to read. Whew, that's a mouthful, right? But it's kind of nice to work with right now. The API, at least all the types are like in place. We're implementing now that logic, right? For actually going through the buffers, reading things. And of course, that's where the real hard part is. We just spent maybe 2 hours trying to find a nice API for the user at the type level, so it composes nicely. So now we need to make it work. And for that, we were reading a lot of Rust code, standard library implementations of things. Do you have any experience with stations on the stream? Anybody that can help me understand how does the field buffering work? And on occasion, we are tweeting about what we're doing here. Will it never end? Aye, aye. I need to get to this. I built a custom GPT for OCaml, and we want to buy the OCaml AI domain to run it there. But it's like 168 bucks, euros, quid. Um, we did get. Thanks, man, to me. Have a good one, you too. Take care. And thanks for the raid. Okay, back to this before I lose the understanding. When you do a read on a buffered source, right? We check if the buffer is full, right? And the thing we need to fill, the outer buffer, is bigger than our capacity. Then that means we actually need to clean the buffer, and we can just sort of bypass. Does that mean this bypasses the buffer after the initial buffering? If we don't have any buffer data and we're doing a massive read, right? Duh. We could have read that comment. It would have been easier. Now, otherwise, right? We wanna. Oh, okay, that makes sense. So this is what we care about, right? This is just an optimization. So, how do we do a buffer reading, right? We read stuff into our buffer, right? right? And then we copy our buffer into um, outer. That's it. That's really it. And then we just move the offset position in our buffer. We can return how much we read. But sorry, Chad, I borked. I think I would need some food sometimes. Fuel. So we're calling field buffer, right? And right now field buffer is actually operating on the current buffer. So I don't think we were taking the right step there. Like field buffer really just going into the inner buffer, right? Into tbuff, and tries to read tries to fill this thing, right? From t.inner. Leia, I have a cat here. Her name is Leia. She might pop into the stream every now and then. So if you hear me talking in a cat voice, that's me talking to her. So we really want to just copy from inner into the buffer, right? So our field buff function maybe is not so bad, but instead of the API might be different. Maybe it's like something like this, right? So we call field buffer and we say, I have this reader, right, that will read something. And here is the buffer that I want you to fill. And that happens to be the internal buffer, right? Here. And then we just move our buffer offset. Hey, Leia. Yes, you can come in a little bit. It's fine. Nobody allergic to cats? All good? This is Leia. She likes to lay down here. I don't know if that's what she's going to go for, but okay. Like this. Now that makes more sense. But now this field buff, right, is not implemented in terms of the read interface. This is just a function, right? Wait, I'm in the wrong file. Yeah, here. It's a function defined in buffer rs. So buff reader, right, has this thing here. And no, sorry, it is defined in terms of read, which we cannot do because OCaml doesn't have traits, right? So instead, what we have to do is just say, okay, field buffer is going to be defined up here, right? Which is accessible to that. And what he wants to do is say, I'm going to call the reader, right? And I'm going to call the field buff function on that, so that whatever it is that we're reading, it reads up to that amount in that buffer. Oh, Privan is back. We are back. Okay. So maybe it will be okay to implement this by bypassing the module itself, reader. But I don't think that will work. Really, these functions are just dispatching, right, from the reader module into whatever function they need to work with. The king's back. Yeah, exactly. This is what it is, right? Seriously though, shout out, shout, shout, what? Shout out? Is that how you say it? Shout out. Shout out to Privan. My God. Do follow Privan. I don't follow you. Oh my God. Look at that. I follow you now. Yeah, I'm not good at the follow back game. I just forget. All right, so now that we have that, we can. We don't really want to use that one. I think this one's good to have, but we may want to implement one right here, right? Let fill buff. And then we get a source reader. So very, very similar interface, right? No, no, my dream is that like 0 followers, right? Infinite following. The ratio is bad. Anyways, you know what I'm talking about. Um, Also, no, that sounds very sad. It's like I want my feed full of stuff. Interesting stuff, though. A lot of people that I don't follow because I don't find it interesting. And a lot of people that I don't follow because I forget to click. So, like, all right, nice tweet. I'm going to like that. And then I go on. So, the point here is that we get a reader, right? And we have our buffer. But we need to be able to call read buff. Oh, read buff. Right. That makes so much more sense. So field buff is just read buff from the inner. And you're like, what? What's happening? Read buff. And I actually think read buff can be derived. I don't think I follow you on Twitter though. Just saying. So read buff. Hold on a minute. What you saying? I think maybe read buffer. I don't know if read buffer is the one to implement inside of the buffer. But my guess is that we might be able to implement that from read alone. I guess I do follow you. That just goes to show how bad I am at keeping track of these things. So we want to look into trait read. No, fuck. My God, seriously? Where are we? Why do you do this, GitHub? This is such a garbage way of not... Okay, I'm done with this. I'm sorry. I'm just going to clone the repo and use reasonable tools to work with it. Rust lag, Rust. Look at that. I already had it. Ooh, it's going to be a biggie. When's the last time I checked that repo? Oh no, that was fine. Okay, I just had a shallow repo. By the way, when we had the raid, did you see the splash animation, the thingy, or did you not? Oh, we don't need the whole thing. All right. Pub, trait, read. Come on, find it. And it looks like it's this one. 613. Kind of want that layout, but split differently. Okay, I'm gonna do that, and I'm gonna split here. Now, all right. If you are gonna kick everything, you go it. Evolve and do an exec. There you go. Cool. That makes more sense. We're gonna be reading a bunch of Rust code, and okay. So pub trait read, right? Yeah, so I normally run tmux, Kitty, tmux, and Neovim. And then for Mac, I have Rectangle with some nice bindings as well. So everything is HACKATHON, right? Inside of tmux, in like the paints, right? Inside of Vim, right? The buffers as well. And then same key bindings with a different modifier for Rectangle to go like bottom, right? Up, left, right. More than sick is like, I could not use anything else if it wasn't that. Pretty dumb in that space. Read buff. Default read buff. Okay, so this is what it is. I term for muck. Damn. That is not a happy life. I'm confused. So this is just calling read? Where does read come from? Oh, it's an input. Okay. Again, it's relying on traits. Of course, it makes sense, right? So they get a buffer, they want to read, and they have a T, which is the reader itself. So they create this little function that takes a closure, right? And that closure is calling self.read. And this self, right, is this self over here. And this borrow cursor seems to be used for some black magic, right, that ends up as this B. So let's see, why don't I have the Rust analyzer? I thought I had it. Okay, so if I reload, all right, so we have the Rust analyzer there. Cool, save. I'm gonna read this module. It's gonna take ages to load, if it loads at all. But yeah, you can see here how we grab the cursor, we do some ensure initialized, and when you try to do an initialize as mutable, I guess. Yeah. So our function is really gonna get one of this. which means by default, there should be an implementation for this, right? So impl read for, and I guess that's going to be, if we search, it's going to be one file that has a bunch of those. Looks like this is it, IO impulse. Não, leia. Não pode, man. Não. There we go. I don't even need to use this thing. Cool, see? And we have the implementation there, and there's read, right? And then it just advances the buffer, which is fine. So we want to do something like this, right? We have self, which is us, and we already have that defined here in b.read, right? Which is great. And we have a buffer that we want to use. So we don't even have to do that initialization magic, right? We just have to call. Really? Is that it? If it's going to be the same, then why do we have it? Nope. If we don't need it, we don't need it. That's okay. So this will read from inner into our buffer. And the result here, okay. Could either be abort, because something went wrong, could be read. And if we read, then that's our offset, right? Não, leia. Não, não pode. Leia, leia. Meu Deus, você não compreende. What do you want to lay down here? Okay, but you gotta behave, okay? She's the fucking cutest. But also kind of a pain in the ass sometimes. Alright, I'm gonna make some more room for you. Cool. But if you stay there, you stay there, okay? Yeah, exactly. Yeah, it's like, I have something better for you to do. So off. Oh! 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 Do you see that? It worked! The test fucking passed! We managed to read. With a capacity of 8, we still managed to read. How the fuck did that happen? That doesn't seem right. So, if we do capacity 2, then did that still work? If we do capacity 1,000... I guess we have more bytes than we expected there. No, that seems wrong. Okay, there's something weird here. You want to sell her? Damn, this is like a private chat with Privan. Hey, everyone else, what are you up to? We're gonna go play the best album rock and roll has ever made or ever had. If I find it, where the hell are the albums? Where is it? Yeah, we can do country. You send me something. I have a broad range of musical likes. I don't even know if that's the right way of saying it. Luke Combs. Luke Combs. Who is that human? Okay, I guess we're listening to Luke Combs now. Oh, Fast Car. Did he make that? Is that his own professional song? When it rains, it pours. Right, we're listening to this now. Damn, yeah. Good country music is that way, you know? Like, no other way around it. What I'm not understanding is how did this work? Okay, but I need a minute. Okay, we're gonna go into the coming back screen in just 1 second, and I will be right back. And we're back. Just settling back in here. What did I miss? Chat not much. Cool. Reopening stats. Recalibrating the sensors. All right, let's do this. Coding. Cool. What did we have? We don't need that anymore, or for now. We essentially read back into this. We were trying to implement buffer reads in OCaml for Riot. Okay, this may be a little too country for me. I don't know, I just don't get much from it. So, next song. What is this? Isn't this like the last song? Oh, we got some follows from that raid. Cool. Foo Force and Chaotic Monkey, if you're still around, thanks for the follow. I think I'm just gonna. Ooh, this reminds me of John Butler Trio. That's a hell of a thing to listen to. Albums, show. Where's there's one song that I want. I forget it. Okay, yeah, like 4 songs. Where are they from? Right, this is a debut EP. Crazy good. So we're gonna listen to this now, and then we're gonna go do something else. I think you like this, Privan. It has a little bit of a groove, right? It takes you. Yeah, we get some action here. Cool. So, buffered a reader. Get a buffer around one of those. Cool. So that should also work. And I expect this to work fine, right? since we're just reading the entire file. When we go through read, we essentially go here, right? And that will take us to file, read, right? And then we're going, this is the lower levels. And this is where, like, if we call these functions, we are safe, as in, this will suspend if they need to. So we're completely cool. And we're passing the buffer as a C-struct, so we're really just like exposing, right, the inners of the buffer, which is fine. And the buffer is big enough to hold this. If we made a buffer of like 5 characters, then, you know, it will just read bytes into it. I guess the buffer in the middle, right, still works, because, yeah, because it's smaller than, and that works fine. What I'm confused about is why, because I guess it's going in here, and we're just consuming and then returning how much we read, right? So let's do a logger here. Error fun f buffered read, and then we'll do don't the bytes there. So we're not really coming here, but maybe we are read bypass, right? Maybe we're here, and we are. Okay, no problem, right? So we have a capacity, and we would like this. Let's use the default capacity, which is pretty large. And now we get a buffer read, right? And we read everything, including, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But we have one last byte, which is the, you would think, right? Why are we reading garbage? I sound quiet. Maybe I have the microphone misplaced. Is that better? Hey, Felipe Codes. We could do something like that, right? Like have specific effects for, I guess, building the streams, like passing from one handler into the other. I don't think we need to, and in fact, we are using here algebraic effects for doing the scheduling of the I/O, right, itself. So just to walk you through very quickly, right? In the example, we do like open read a file, right, and we do the composition of this thing all nicely. But at the end of the day, when we call read on a buffered, right, and it calls read on the inner buffer, on the inner reader, right, it will end up calling the read implementation of file, which is calling vectorized read operation, right? And this thing is non-blocking, right? And it's using this external little bit of C code, right? So when we get a retry, if we really wanted to read the whole thing, at this point, we can actually do scheduling and say, oh, I want to do a syscall, right? And this is the debug name, like for example, file read, right? And this is the file descriptor I want to listen to. And in this case, T is a file descriptor because we are a file, right? And then you can just say like, all right, I'm just going to wait for that file descriptor to be good, right? So this will block nicely on reads and writes. Block as in it will suspend the current fiber, right? And just let someone else do the work. So you could define all of your pipelines like, okay, this is how I want the IO to flow through, right? And then you just run it. And then it will just be scheduled nicely. The scheduling is still, the unit of scheduling is still a process. So if you want two of these pipelines to run in parallel or concurrently, you would need two processes. But that's, I think it's a very small thing to do. Like we could build a stream module on top of this that is parallel by default, where every time you grab data, we're just like spinning processes to be able to schedule it concurrently or parallelly. Does that make sense to you? Just sanity checking what I'm saying. I think the music is quiet though. All right, it makes sense. Now, what do you think about it? Like, what are your thoughts and opinions on that? So here we're reading, we say that we read 12 bytes, right? But we haven't really moved those into the buffer, right? Into the inner buffer. Or rather, from the inner buffer into the outer buffer. We just read from the inside into our buffer. And this is the part I'm still... Oh, you don't need to do buffering, right? Like, the buffer is a construct that we have here on top of a reader. If you want to just read directly, then you can do that as well. Like I was testing here, right? If I literally like comment out that line, then this thing just passes, right? It is just doing non-buffer reads. It will read until like either the file ends or the buffer is full. So if we do like 8 bytes in a buffer, right? And here buffer is just like the destination of where you're reading to, right? Then you'll see that we actually read less than we need to. But this is a very low level library, right? Like I don't expect you to like use this on a daily basis unless you're building libraries like this. But maybe I misunderstand what you mean. You have an example, or was that what you were talking about? Think away. Think away. If you have a decompressor stream that receives a bounded buffer, right? When you decompress, I guess no. I think you would work with a bounded space, right? Either I guess you would fill the bounded space as long as someone is trying to read from it, right? So you're not decompressing into a buffer. Someone is filling that buffer with your output. Correct. Like at the end of the day, let's say you're trying to read like a compressed file or a decompressed file into a string, right? You don't know how big it's going to be. So you need something that will be of like growable, right? Like a vec in Rust or a string, right? Hmm. Got me thinking there. Yeah, could be. Right. Yeah, and that makes sense. I think we'll deal more with that when we have the right interface, right? It might be that we need to ditch the buffer entirely or hide it. So when you read into a writable, right? And then the writable can be configurable to allocate as needed. Just like we have the buff reader, we will have a buff writer, right? I wonder though if we should maybe make the buffer growable, right? When you create it, or just explicitly say like you know grow by, right? So then a decompressor that receives a buffer, right, can ask, hey, is the buffer full? I still need to write this many bytes, right? Grow the buffer by that many bytes. Which would explain why sometimes you see an inner buffer that is like an array of C struct. Because you want to. Não, leia. Leia. O que está fazendo? You want to be able to quickly say, okay, I'm just going to punch in another C struct, right? Instead of extending the existing one. I think that's how that's why they do it, right? You want to hang out here? Hmm? Yes? Yes. You ate everything? No, you did not. Why didn't you eat everything? You're going to be hungry. Damn! Cute as fuck. You want to say something to the people? Meow. No? Yeah, it's not. Damn, Privan! We got a hype train going! I don't even know what a hype train is, but it's incoming! It could be. I am just sketching out the pattern now, man. So I don't even know if this is going to be the final version of it. I really just need to be able to read from sort of a TLS, right, decoder to get to a. Ooh, you okay? To get to a socket because I cannot read. I cannot like right now. I can't do that. Are you okay? Are you farting? Is that what you're doing? You're farting on stream? Ah, you are cute. Merry Christmas indeed. Damn, we're like 80% on the hype train. Come on, folks. We got like 4 minutes to get 20%. I don't even know how to fill that 20%, but we can do it. Definitely can do it. Sub, gift, hype chat, or use bits to get to the next level. Blame it on the cat, the hype train? Oh, the farts. How do we do this? Viewers. Don't even know what we get by going to level 2 of hype train. Oh, I think it's impossible. Pirate software is just unbelievable. Love their stream. Also, they have a really, really deep voice. It's cool to listen to. I don't know what a Craigasm is. Okay. Enough playing, okay? Let's go back. There we go. Okay, I'm just gonna tweet on that and see what happens. See who cares and what happens. Where's the Twitch? Twitch chat. Hype train just started. Gotta love JavaScript and how there's hype train at different percentages on the phone as it does here. I did the wrong thing. But I think it's still in the copy buffer. No. God damn it. I don't know what I'm doing, folks. There you go. What? Hype train. Folks. Camel. Getting that hype. Oh shit, we got it! Woo, level 2 complete! People are doing this thing. Yeah. I'm not gonna ask you to go all the way to 100% for the level. Anyways, I don't care. Let's go back to the code. It was fun though. Thank you, Sabine, for pushing us through the edge. The edge? No. The finish line. That's the thing. So what we want to know is why on earth we're not reading, right, as much. So what I'm thinking is that there is something that we're doing wrong here, right, when it comes to filling the buffer, right? And we probably want to read until we cannot feed anything anymore, right? So fill buff, right, and we'll get the T. And that will actually be something like this, right? And he will do rec, right? We'll consume, and the first thing we'll check if buffer is full, right? Then we'll just return nothing. Else, actually we can just do, if not buffer is full, right? Then do this thing. And as long as we read something, right? then we'll just recurse. Fill buff T. Did y'all see? Like, did you get to see the the little emotes for the different things, like giving out community subs and stuff like that? Like, is that working? No, there. I guess we could just do that. Eventually, we'll read 0 because there's nothing. There's either nothing more to read or no more room to read it, right? And what do we want to return? So the other two ops we have here, if I can destruct them. Seriously? Okay. One of them is retry, right? Which means whatever you're trying to read from is actually currently busy. Which means you need to do something like runtime. We don't actually know if this is going to, like, this buffer may be tons of things, right? So we don't know if it's gonna be there. What I'm trying to say is, like, there's a syscall, right, function here that we can use for a file descriptor, but our inner buffer may not be a file descriptor at all, right? So we cannot assume that it is and just sometimes like somehow get a descriptor out of it. So I'm thinking that maybe the read interface is wrong, and this really should just be like, you read, and this is how much you read, right? Like that. Which I think is kind of what they have there. Wow, we have new emotes to people? That's amazing. Choo choo. Whatever. Okay. Because, like, the read interface here, right? It just returns, a result of a use size. And it blocks internally. Yeah, we can probably do that. So if we do red or n, right? If n is 0, right, then we just return okay. Else, we recurse. I don't know exactly what the result will be, but I think here they're actually wrapping result. Yeah, it's an IO result. So we will have some sort of IO result, I guess. Just throwing it out there I think it will be helpful since a lot of the results from IO are very, very similar. Yeah, see, like this. Bind. Right. But we kind of want, okay, maybe we'll just do that for now. And we'll see if we need to add more errors there. Cool, 93. That's fine. This interface should now return a unit result, which is good. 93 unit result. And this returns a LL read. No, this returns a unit result. Cool, so line 92, 102. Oh, sorry. This is not a, it's an int result. Do we even have a uint here? No, that's fine. Cool. So this will be off. Line 93. We now need to change the other unit result to be an int result. Tell us how much it read. And now here, when you do read, you actually get the offset, right? Okay, offset. Cool. So we'll have some issues with interfaces now. See you, everyone. Thanks for stopping by. Thanks for the hype. Yeah, and here's where we know we have a file descriptor. So here we can say, hey, I'm gonna try to read, right, from that thing. And I'm actually gonna get a, oh no, that's not what I want to do. Oh my God. Why are you not letting me do that? This is a well-known interface. I wanted to destructure, but I guess it's not happening. Let's go into socket because we have some of that code sketched there already for reading and receiving here, right? So read T buffer, right? And we don't need to create that anymore. We can just pass that in there. And then we don't need to do this splitting anymore. Because that already happened. Cool. IO 72. Right. Four, 3, 7. Four, 4, 3. Cool. So now our test is broken. We just need to fix that because we don't have an operation anymore here. We just have an IO result. And then we'll do result get okay. So this will be the amount that we read. Actually, I think I'm just going to leave it up. But this now will be an okay, right? And then we'll just have an error there. Did that work? No. Why is this working? We're okay, we're not calling field buffer. Right. Field buffer, where do we call that before? Okay, that's good. So I think if we print out a buffer here, right, then we should actually see buffer to string. Oh wait, something went wrong. What did go wrong? That means that's here, right? Unexpected close, okay. I guess this is an okay 0 then. Okay, our buffer is pretty big. Let me make that smaller. Capacity, we want, I don't know, like 15. All right, I see hello world there, right, in our full buffer. I think we're getting there, right? We have unexpected input. The input still is garbage, but that's okay because we just filled the buffer, right? We didn't actually copy that buffer into like whatever you wanted. So read. What am I doing? Right. So we fill the buffer, right? And now we need to sort of copy that buffer, our internal buffer, into into the outer buffer. And that should be essentially buffer copy, right? tbuff into outer. I think. This might be wrong, but we're gonna go with it. Like copy AB, right? Or source test. Cstruct bleed, right? And then we have source 0 dest, right? 0. And Okay, that makes sense. That's broken there. So, field, we call field. Do we, what, we never call this? Field buff. But we are writing there. So who is writing here? How? Oh. Right. So I guess we would have to do some manual bookkeeping here, right? So we call read. We have a number here, right? Offset. So now we can actually go into the buffer and say consume buff off. No confuse. How do we update the field? I think we do that. We're doing that wrong. I think that should be happening here, maybe. Okay, good. That's better. This error is better than nothing. So we're filling that, and we return how much we actually read. My guess is the consume. We're not really using this, right? But it would have to be something like that. And then this fails, same. We do copy 12, right? But we go from 0 to 11. So I wonder if this offset is off by 1. No, it should be fine. We literally don't have enough capacity in the buffer. But that, to me, that should mean that when we do copy, right, we should pick the smaller of the two. So int min, right, of destination capacity and field. So you maybe copy up to capacity, but you never copy the whole, like, over capacity. And that's okay. That fixed the bug. All right, this is definitely not done, like this fight. This work. But at least that worked. So we have buffered readers there, right? Going through the buffer first. And if we remove that and we just run it with a big buffer, it still works. We still get 12 bytes. Wait, how could we read 12 bytes if the buffer capacity was 11? That seems wrong. Seems like we're dropping some information somewhere. Now that makes sense, right? If we only have 8 bytes here, then we can only read up to 8, right? But, and I think this would be interesting, if we have a second buffer, right, then we should be able to read into it again. String 2. I guess, does that read again? Is that the expected behavior? You read into a buffer and you hit the limit. Felipe, are you still around? Because I think this is the behavior that you were mentioning, right? Like I have a reader. It doesn't have to be buffer, I think. Well, that's weird. I have a buffer reader, and I have a buffer of 8, so I read up to that capacity, right? And then I just make a new buffer, right, of 8 again, right, to keep reading, and I read. What would you expect that to read into the second buffer? Everything from the beginning again, or the rest? That makes sense, because otherwise you wouldn't be able to sort of go through a really big file, right? Yeah. And if I remove this other thing, right? You'll see that we actually wrote 8 bytes. When you do read, up will be okay, and it's like 8 bytes. But more importantly, you're saying because maybe read will take an offset? I was actually thinking that because it's buffered, right? Then if you call read once, you can fill up to that thing. But if you call it again, then the buffered bit knows what offset you're in, right, on that buffer, and can just continue from where you left. Which I think is the behavior of the buff reader in Rust. Okay, that's no bueno. Because position minus field should be is it source capacity? Yeah, I think that was that. Like you grab the capacity, right? And then you subtract, I think, just the position actually. And this will be like the offset, right? And the actual field, the length, will be either the capacity that you can write or as much as it fits on this buffer. Yeah, and we read Earled, right? Let me add some logs here and see what the hell happened, right? So logger, error, fun. Read one, number one, reads this many bytes up. Fine. Result kit, okay. And the second read, right, should read less bytes. Why do they read both? Both of them read 8 bytes. The length, your reader could be doing something that is read block by block. You would have to break a block to match output buffer capacity exactly, which you have to do anyway so the buffer is smaller than the sources block. Prior art. Let me open the link. Zero copy stream. Right, and I actually have a function for that, right? Called fill. And fill grabs the buffer and grabs some raw data, right? And it will fill the buffer. And why is it putting back to 0? Maybe this is, I mean, I'm not really using this function anyways. So we want to read into outer. An outer may have like 8 bytes, right? So we fill our buffer internally, and then we copy our buffer there. And our buffer may be bigger than outer, and that's fine. So copy will just copy whatever, however much fits into outer. That, I think that part is working, right? So what doesn't make sense is like on the second copy, on the second time around, right? Oh, actually, I think maybe this might be filled, not position. So I would expect us to see a changing number in copy, right? I don't know why it starts at 12. Let's look at how field buffer behaves. So we say field buff, right? And we have a T buff position and a T buff fill, right? So it's 0 and 0 first, that's fine. And then we also going to do capacity here. I think that's going to be a big number, but we can make that smaller. Oops. Cool. So we have the capacity, the current position, the current fill. It begins in 0, makes sense, right? So we read, and we're going to put that there, and we're going to say read bytes. And we're going to put off here. Debuff, it's already there. Off. Save, run. So the first time around, we read 12 bytes. And that's fine, because that's the size of the file, right? And it fits in the capacity. So just for my own education here, I'm going to do a capacity 10. I would expect it to read 10 bytes. Yeah, exactly. Reads 10. The second time around, right, fill buff reads 2 bytes. Why does it read 2 bytes? This should be filled. So first problem we have here is that we should not be filling the buffer if the buffer is full, right? If buffer is full, buff, then okay. That makes more sense. I am missing. Wait, is the buffer full initially? So if it's empty, the position is 0 and field is 0, right? And we're full if we're not empty, and also position is equals to field. Subtle but important difference, right? Like these things. Because if it's all 0, then you're not full, you're just empty. Cool. So that makes more sense to me, right? Like we go through fill buff, right? Capacity is 10, position 0, fill 0. We read 10 bytes, right? And we go into copy. We copy 10 bytes, and the field is 0. Why do we do that? Copy. We do blit. We go copy, and why is that 0? Capacity. Capacity is the max length, and the position is where we currently are, right? So that's the amount. I actually think it is filled. I don't know why it is that. So I would expect fill. Maybe the destination capacity is 0. Destination capacity is 8. So we're gonna copy. We're in position 10, field 10, right? And we're gonna copy into a buffer of 8. The smaller of the two, right? If the buffer is 1,000 capacity, then 8 fits. We just copy 8. If the buffer capacity is 2, and we have 8 to copy, then we just copy 2. Right, so bleeding for us goes from 0 to actual fill. So this makes more sense, right? If we look at the logs here, it's like we're gonna fill the buffer, capacity 10, position 0, fill 0. It's empty, right? And we read 10 bytes. So now we have the copy function, and we're trying to copy our buffer, which is like a 10 on both position and fill, to destination buffer with 8 bytes. And that means we only write 8 bytes, and we can confirm that because the operation reads 8 bytes, right, into the buffer. And then the second time, I mean, that's the first time around. Second time around, we can definitely do some work in the resetting here, but essentially this moved back, right, 2 bytes, which I think is the diff of what we actually read. And I can see that happens. Where does that happen? Here. So if we read 8, then we put the position back to 8, which is the amount we read, right? And we can keep writing there. And then the second read in a capacity of 10, right? And position of 8, fill is 10. It reads 2 bytes. So this seems to be working out. I think I'm missing a byte here. I think we should have 11 in total. So 8 and 3 instead. So I'm wondering if after we fill the buffer, right, and we copy things over, then there's stuff that we maybe didn't get to copy, right? So we just move the position to 8 because that's the last the last byte we copied, right, out. But the field shouldn't be 10. I guess field buff fixes that. So what happens if we have an extremely large buffer here? So field buff, we feed it the 12 bytes, it's fine, but we copy 8. That's as much as we can put in there, right? And we want to actually, I think it's fill minus position that we want to do, because that will give us the amount of bytes that we're missing. Right? 4. We read 8, we need 4 more. So if we go into copy, and this will be field minus position. Maybe not. 0, 0, first copy, 12, 12, right? And then we go into copy with how much did we go into copy with? 8 and 4 and 12. Or maybe it's a matter of copying from the source, right? Source position. That should fail much more loudly. So the position should be changing, and it does, to 8. That's good. And then we do field buff, and we don't read anything because the file is closed. That's fine. And now that means we do copy position 8, right? Field 12. This had in the struct somewhere here. Position is always less than field. That's good. So far we're good, right? From position to field. I just don't like that this we're reading this 8 bytes. We should be reading 4. So field is going to be 12. Capacity is going to be 8, right? What was I saying the right thing and doing the wrong thing, or vice versa? Because I expect field. Why are we resetting the position? Position 0, 0. And we'll just do an absolute here. Nope. So again, first time around we read fine 0 0. We go into copy with 12 12, right? Second time around we go position 8, great. Field 12, great. And here we are choosing to write, right? Actual fill. And that's not what we want. And if we do source position, then that should be 4. I am very confused. Okay, so there's something wrong with how we're moving the position, right? Which I think is fine. Just need to fix that. Consume, source, actual fill. Maybe we want to do it here. What? We copy that much, we move the position perfectly forward, and then we go back into filling the buffer. She's fine. We try to read again. And then we go back into copy. But the way we compute how much to copy is wrong. It should not be filled. It should be filled minus position, like the whatever is left there, right? But when we do that, right, we get 0. So we just read 0 bytes. It's kind of weird though, because we read 12 bytes into this thing, right? And then we go into copy, right? Oh, what? Okay, why are we moving the consume there? I think that's a problem here. When we fill, we should just increase the field. There we go. That makes more sense, right? So field buffer, right? We increased we read 12 into that. So we go over again and ask, are we full? We're not, right? But this time around, we read nothing more. And this is for the case where we have a really large buffer, right? So now we go into copying and say, okay, we need to copy up to 12 into 8. And that means we're going to copy 8. So we end up reading into that buffer, copying 8 bytes. And then when we come back around, we already have copied 8, so we remember that. And now we have to copy the difference between that. We do try to read again, just in case there is something there, but we read nothing. So we proceed to copy, and now we do the right thing and copy sort of the 4 bytes left that are already filled into the buffer of 8, right? Which gives us this buffer here. I think that works. Let's actually do with a smaller buffer again and see if the numbers there track to. Nope. So we have a bug there. Different kind of bug though. So if the buffer is large enough, then we will do the right thing. And I think our assertions here are just off because we have unexpected input. And this will be 4, right? The first string should be equals to hello world, right? And the second string, actually we can just add them together. Perfect. And when we do buffer to string, we shouldn't use the capacity, we should use the field. The position? Really? If we do capacity, then we get all that garbage. It is not going to be from position up to field, right? I think it should just be field from 0. Like, give me everything that's in the buffer right now, right? Let's see. If we debug the buffer like this, to string, position, we don't actually have much more than that, so position and field. I'm sorry, what? I am calling with capacity, and we're reading to that buffer, but we're not updating that buffer. Whew. Right, so that should happen in copy. We bleed into that thing, right? And we should then consume from this test actual fill. Right? No, really, that passes? Okay, so that works, right? For unbounded, like really large buffer sizes. But when we have a smaller one, like 10, then what is the problem here? We are reading like garbage. And I think the problem here is that when the buffer is small, right, it never gets full. So maybe when we fill the buffer, we should not be recursing like that. Because this will recurse is ready. We want to check if the buffer is I guess we want to check if the position is equals to filled, right? Maybe the original check was okay. I don't know. So first round, it is empty. So position and fill are 0 both, right? And we read 10 bytes. And now we move the field upwards, right? And now the position is 0 still, right? But we cannot really fit more data because we know that the capacity and the field are the same. If it's the same, then we can't really feel anything, so we just escape. Let's see that. Okay, better. Let's see if it fails with a super large buffer. Super large buffer is still working. Cool. Now, what was the problem with the smaller one here? We read 10 bytes. We can only fit 8, so we do 8. Then we read 2, right? Oh, okay, so it's just a assertion failure. Unexpected input, 2 bytes, right? The last read is just 2, because we read 10 first. No, that seems wrong. We're losing bytes here, people. We're losing 2 bytes. And the problem, where's the problem? So we read 8, right? We could read only 8, so we move the position to 8. We're still filled at 10, right? Right, so then that's not going to read anymore. Which probably means that when we copy the whole thing, right, into the destination, we kind of want to discard the current buffer. Just be like, all right, we're going to go back to 0, right? Don't know where the right place to do that is. Definitely not here, right? But we copy, and if we copied 8, right? So maybe it's a matter of saying if the no, we really need to backtrack the field so that this will read again. I think we need something like this. The position is bigger than filled. We read that. I think it's actually the other way around. And I copied that wrong. Ha 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 ha, yeah. I think I'm gonna order some food. Fuck. It got really expensive to order anything. They don't have big cups. God damn it. I think I'm gonna have to go buy food and be back. That sucks. I mean, it's okay. But, yeah, never mind. I think I found a place. Cool. So put in the order here. Mm-hmm. Look for love, love, laughter. Bam, 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 bam. Okay, so order placed. Food will be here in like 40 minutes or so. So we'll do a break there, maybe like an hour. Then we'll come back. Okay. So what was the problem here? We read 10 bytes, we fill 10 bytes, right? Position is 0, we write 8 bytes, that's fine. And now we want to read more, right? And we need to read 4. But I think so. There's a check here that I need to figure out. Because if we wrote 8, right? Then there's still like 2 bytes to write out, right? Is the problem that we need to do more calls to this? Like this? Nope, that is not it. So I think this is right. I think we should not be reading more because the buffer is 8, right? And we flushed out 8. We still have 2 to flush out, right? However, I get the impression that this wouldn't be a problem if we had 10. No, actually, 12, which is what we need to write, right? Yeah, that's right. So if we read everything into the buffer, we're good. Problem is when we don't, right? And that, I think that means that we have, we need to do a little more looping here. Because if the buffer is full, if we don't read anything more into that, which is fine, right? Then here, this copying, right, might need to do some more work. Is this the new Wolf? Oh, Wolf Mother. I thought it was the other band. I love this band. Good energy. So what I kind of want to do is if the copied right is less than the length. No, wait. Does that make sense? Yeah, if we have not filled the outer buffer, right, then we should try to fill our internal buffer and then work again. Even if we did a third one, right, with a new buffer. This is trying to write 8 bytes. That makes no sense. So consumed. So if we copy less, I don't quite like the way we're doing this, but we fill our buffer and that's working fine, right? And then we copy our buffer into the destination and we have it copied. And we have, so there's some stuff that, like the diff, I guess, between the size of a buffer, right, and what we copied, that, I think that should be our position. Right, so if tbuff position, so tbuff position got to 8, right, in this buffer. And we have 10, right? So we need to read those two. Or write those two, right? Out. Right. If tbuff position is less than filled, then we consume copied and just move upwards. Otherwise, we want to reset the thing. And I think that will make sense because then we can actually do a third read, right? And the third read should only read 2 bytes. And it does not. Fuck. Come on. All right, what am I missing here? Just checking the chat. Whoa, thanks for the subscription, Metomi. Thank you for supporting the caravan. Alright, so we get how much we copied, right? That's good. And now we know that we copied 8 first, 2 again. And usually what we do is just move that here, right? The problem is that, wait, how did they do it? Oh my god! Seriously? That makes so much more sense. So that gives us the right amount. So the position gets filled up to 8, which is fine. And I guess every time we copy, and that's this fill buff on the right, we're actually going source position. Wait. Okay, so we do need to do that deinitialization. That's fine. Where do we do that? We call fill buffer where? No, sorry. Fill buff. So we fill the buffer, right? By reading, and once the buffer is finished, then we do a copy. And there, I guess we're just we're just resetting. The position is back to 0. Why do we do that? This here is our copy function, right? From our buffer, whatever we did read there. Oh, wait. I know the problem. Source. Duh. So every time, right, we fill the buffer, we are doing that reset. Like if we manage to get full, right? But we also always return a buffer, like something we can copy from. So in this case, it's like we're just filling up the thing, and then once we're done, once we like get to capacity, which yeah, we want to return sort of the contents, right? We want to do the reset here, like right here, right? And this would be like t buff position, right? Fucking 0, t buff. Filled 0, right? We don't want to really copy the buffer into another thing. But we want to do a new buffer, right? That will return. Where field will be t buff filled before we do that, right? Okay, nope. So the problem is that we're not resetting the buffer, right? So then we just go into reading zero, nothing. And we kind of want to do that at some point when position is equals to fill, right? That means we've actually consumed everything, so we can reset that. And I think that's something that they're doing in the fill, right? They sort of like buff position, right? If it's bigger or equals than t buff filled, right? Then buff position. I think that makes more sense. We read 10 bytes, right? We fill is up, position is 0. So now we flush out 8 bytes, position is 8, fill is 10. And now we actually need to flush out 2 bytes. So we do that, and then we read 2 bytes in, and then we flush out the last 2 bytes. So for a small buffer, that would actually be correct. And this is failing because we're checking for 4 bytes instead of 2. And also because we should probably concatenate all the strings together. Like S through 3. That was it, right? And if we do a really big buffer read, then that should be fine. Like you should just read nothing into the other strings. And that failed. Which makes sense. So if we actually number these things, right? 2 and 3. Not a fan of this, but up 1, up 2, up 3, right? Then we want to see 8, okay 2, okay 2, right? We get S string 1, string 2, and string 3, right? Bam, bam, bam. 1, 2, and then 3. It's kind of annoying test. A lot of, if we need to do many writes, then we have to handle all of them, which is not ideal. And this will be string 1. Cool. Let's put 3 strings here, string 1, string 2, string 3. And Esther is missing, because that should probably be more like this. unexpected close, read that. And except we don't really have a Unix error here, so we can get rid of that. Come on, what are we missing? OK1, OK2, OK3. I guess it's gonna be more kinds of errors here, right? Right. Where are you expecting the in? Oh, great. Cool. So capacity 1,000, that works fine, right? Capacity 7. Hmm. Okay. Another edge case, I guess. So maybe we want to put this in a test, in a function, right? Let's say test with buffer capacity. And we will do that. So test with buffer 2, right? And we want to do like 10, and we want to do 1,000. So the first one is broken. Cool. So this first one is doing numbers, right? Like 7 was the first buffer. Less than the target buffers. More than the target buffer, but less than the input, the source. Larger than the target, more, yeah, smaller. Larger, right? But smaller. Larger than the target buffer and the source. Hi, Weech. How's it going? Hi, Felix. Hey, Swiss. The mate? The mate? It's almost 1 in the morning. I'm not gonna drink mate. In the editor, this one is called Deep Space. Color scheme. I think it's that. I forget how to set it. Yeah, color scheme, Deep Space. And in light mode, I like to use tomorrow. No, to be honest, I don't drink mate regularly. I just never got into the habit of doing that. And then I spent so many years in countries that didn't have good mate sort of ecosystems. So I ended up not drinking it as often. I did become more of a coffee person though. You know what? We're gonna fix this for a second here, because I will love this window to be gone from the stream. Since you already see that, right? I just don't know how to do that. But maybe it'll be okay. Like I thought I could hide it behind my face here, right? But no, 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 no. Like come on, it's just more available, right? It's like a lot of people write go better than OCaml confirmed. I don't know, man. Like I don't think so. Availability is not defining of quality, unless there's none. If there's none, then it can't be any good because there's none. Yeah, the hypotheticals. If there was any, then it'd be good. But it's all good there. No worries. Okay, so we're working now through this test case where the buffer we're using, right, is smaller than the target buffers and smaller than the source. The other two are passing, which is great. Okay, okay. We just have a lot of debug logs right now that we'll get rid of. But this one, this use case is not passing, so we need to make that pass. So you can see here we are reading hello W, right? So 1, 2, 3, 4, 5, 6, 7. We read 7 in the first go. That's excellent, right? Now the second time around, on the second operation that we do, right? Things go awry a little bit. So back to the code, right? We're not using this field function. That's fine. We go into field buff, right? And we say, okay, we have an empty buffer. That's fine, right? We do a quick reset here if we need to. Okay, my food is on its way. We do a quick reset, that's fine. And then we check if the capacity, right, is equals to the fill. It's not. So we're gonna go in here and read. And so we read 7 bytes, right, which is most of this fits on our internal buffer right now. And that's great. We try to fill again. We realize capacity, we're at capacity, so that's where it ends. And then we go back into our read. Now we filled our buffer. So now we can copy that buffer into the outer buffer. And that takes us to the copy function. So I'll keep those open like here, left and right. I think we don't need Rust anymore for now. So field buff below, god damn it. Yep, and then here we're gonna go to copy. Close that. So we do copy position 0, field 7, destination 8, so we can copy really 7. So that's what we copy, and then you see read 1 returns 7 bytes, which is hello to W, right? H through W. Now, for some reason, the second time around, right, we just immediately go into read 2. So calling read there is skipping things. So I'm going to remove that edge case, or rather that optimization they do here, and run this again and see what we come up with. Okay, so that worked. That passes all the 3 tests, right? For 7, capacity 7, 10, and 100. Okay, so then that that has something to do with that, right? Why? Let's do a little log, just like we had that. We'll do a little log here. We'll do read, and we don't have the offset. So it sounds to me like we want to do that reset a little earlier, like here. Boom. That seems good. So let's see if we do 4. I think this is the smallest buffer we can do to read everything in 3 operations, right? And that still works. And if we do 3, then we should be missing some. Yeah, fail. Hello world. Which makes sense. We're missing content. Smallest buffer there will work. And then we have smaller than the target and the source. Yeah, and then we just do shutdown. We can do a little sleep here. So we print nicely. Cool. All right, so that worked. So we can get rid of all of our error logs here. And all of our error logs here. We can make those debugs because they're super useful, but cool. Do test. I think we might need to change that into fixtures like that. Tune test, tune test. Nice. Woo! That's excellent. We can do buffer reads, everybody, in different ways, with small buffers, big buffers, all sorts of things. I think we could try one weird thing here and see what happens, right? If the destination buffer always has 4 bytes. We should be able to read that with all of them, right? Because at the end of the day, we just need to read 12 characters, right? Oh yeah, sorry. I need to figure out how to do that nicely. Hello world. Well, that doesn't look right. All right, I need to go pick up the food. I will be right back, leaving you folks with this lovely screen. And we're back. So, almost. Small problem, right? When the buffer, when we when we read, we have a buffer capacity of 7. Right, we have a small edge case here, right? where we read first more than one of the single writes, right? So here we read 7, and then here we write 3, right? Read 7, write 4, and here read 0 because we have stuff, right? Or we do read something, yeah. Field buffer. Yeah, we don't read anything, but we write 4 because that's the data we have available, right? And then here we actually read 5, but write 4. And I think that's fine. I think that's just, that's not going to work. I wonder if 5 is the minimum that we would use here. So we read 4 bytes, right? And we're left with 6, right? And then here we don't actually end up reading anything else because we have enough to feel like to do the 3 operations at once. Interesting. Okay. Wait, that used to work, didn't it? And I think we should be able to use the same buffer for everything, yeah. Which is also more realistic. Like, if we want to implement the read, like, to string, for example, then easy peasy. We just make a buffer, right? And we read into that, and we keep reading until the operation reads nothing. Is that how we would do this? We can just collect the different buffers, right? As we go reading until eventually we would read nothing. We'll see. Maybe there's better ways of doing that. So I'm going to change the errors here. No, sorry. Error like that. No, actually, I want to do logger. But logger trace. That seems like useful messages to have around to be able to debug things, but we don't want to see them around all the time. Cool, just need to change that again. Cool. So you can see there's quite a number of weird files created. We're not going to commit this interface yet because we want to start using something like this, right? So I'm going to go into feed IO reads. And we'll need a writer as well at some point, but we'll start with the reader. So What we need as well, because we have a reader for file, right? File ML. We need one of these for socket. And we need a stream socket here. Thankfully, we already have implemented our receive function. leave IO. I think we're gonna. All right, fine. Okay, yeah, I need the other IO first. Hi. Okay. Do a build. IO buffer. Cool. So that makes more sense. Libnet socket MLI. You're gonna have some changes there. So receive is now gonna take a buffer, right? Leave IO buffer T. Actually, I don't know if I care about this interface here. That makes more sense. Libnet socket line 100. Really? IO buffer is not compatible with that. Really? So that should be a little easier to work with, I believe. Riot ML. What's your problem here? Receive. Right, we're missing an error here. IOML. This needs a timeout. A little closer. Riot MLI, and then we have IO, and then we need that type there. Boom. Wait, no. Really? Yeah, I thought that was that. .508. IO results. I think we actually want some more flexibility here, right? Okay, so then the problem, yeah, okay, we'll have to sort of add an error here like we did down, where is it? Go back a little bit. Here. 436 on this file. What's the problem? Buffer and buffer. Why? So there's some code here like netml that's using this buffer. Really? Is that your problem? Line 108. Receive IO buffer. And then we're calling that with what? With exactly that. Timeout's fine. We get an FD and a stream socket. I think we're using that interface right now. There we go. Net test 24. We don't need that. We can do buffer, IO buffer with capacity. What are we trying to do here? We received, so that's copied. So buffer sub. Yeah, I guess it makes sense for us to have something like that. To go like, all right, this is the smaller version, same buffer. buffer, and we'll do both sub, and we'll do t of int and len int. So now we can do the same thing here, because this send interface is pretty dumb. So we can do write v, and we can just set the data here, right? IO buffer SC struct data. $118. I'm confused. I have changed the type. Let's see. Ah. $124 right here, right V. Don't we have that? That's IOML, and this should be a right, of course. IOML, right B, and this should be root. Lib.io IML, line 72. So this would be root. libnetml 125. IO buffer. Great. So test net test, right? I think we'll just need to change some of the data types here. So yeah, big string of string, we just need buffer, IO buffer of string. Just give me the string. That's all. I'll take care of the rest. Hello world. With capacity, 82, send main. Oh my god, we don't need any of this garbage. So we want to do buffer substring, right? Actually, to string. Down. All right, so most tests are good, just good. The network test is failed. It says empty payload. And why? Why does it say that? It doesn't really log anything else, so I'm gonna assume that we are reading. We're calling receive okay. Got no logs being eaten or anything. What's the problem here? We call receive straight on this thing, and there's more than enough capacity for hello world. Maybe I want to do debug. Oh, this should be error for sure. Client sent 11 bytes, server received, server sent 11 bytes, client received 11 bytes. Where are the 11 bytes? Where are the bytes? I think this is where the Riot interface gets a little tricky. Because when we do this, right, we are essentially bypassing the buffer. So here, receive really, right? Gets these bytes, but it's not really like moving the field, right? So if we did something like buff field, right, len, then that'll be okay. But I don't like doing that. And then again, this lower layer, right? It's too low level to do anything else. Yeah. Maybe we need to do that there. All right, fuck it. Let's say it goes there, right? Ooh, look at our test passing. You know, I'm gonna make one change because where the hell did we put the time? P10 clock now. TS. On log. To time. Okay, so let's say we get the time there. BP, can we format the time? I just want to format time. So we have a time thing here, but we don't have anything to print it with. So print time. Put the printing. Okay, so fit use new buffers on receives on net ops. Cool. So now that we have that, right? We can try. Shit, I forgot about the food. All right, so we have that. That's great. Some of this stuff's gonna fail. That's not a problem. But that means we can go back to Blink. Freaking finally, right? And we have a socket, right? And we need to figure out how to wrap this into a reader. Oof, that's gonna be interesting. Hey, the same vein motion. Did you work on build systems at Jane Street? Are you serious? This is like the second person the last 2 days asking this. I don't work on build systems at Jane Street. I had a startup where we built a build system called Warp. And this is the code that was left after the startup crashed. Rory Pants and T-Booty-Janto. Thanks for the follow, folks. Glad to have you on board. Ooh, we're closing 9 hours. All right, I think it's a good time to do a little break and eat something. So I haven't eaten anything in like 9 hours. And my food is right there waiting for me. But when we're back, right, we're gonna start wrapping this socket connection, right, into TLS. So the TLS thing can read from that. So it's, yeah, when we do client of FD essentially, right, we need to figure out how to make the engine pull, or rather, when we pull data from the TLS, right, it will pull data from the socket, feed it into the engine, right, and then push it out if it's correct, if it's good. And yeah, hopefully that will work and it will be fun. Whew. Probably some things have changed here. Like we don't use big string IF anymore. We will use buffer, IO buffer, for example. And this receive buffer will not be a regular buffer. It will just be an IO buffer with capacity. Yeah, we have a read and write, so we definitely will need IO writer as well. But I think that's gonna be easier because you don't do buffer writers. You do buffer writers. What am I talking? Repo, Rustlang, Rust, buff writer. We definitely have a buff writer. Cool. On the bright side, we're learning so much about how like Rust works internally, right? Yeah, exactly this, right? We connect, we get a socket with, say, buff writer on that socket. For us, it's going to be a little more like um, network, right? Socket to writer, right? Sock, and then you get a writer here. But then after that, we can actually keep wrapping that and so on. So this will be, I'm excited. I'm really excited about this. Fuck, I need to go eat. Otherwise, it will be an entire day without me eating anything. Yes. So, I will be back in like 20 to 30 minutes. And when I'm back, and I'll write this down big somewhere so we remember. Do you think I'm going to see this if I come back to this, right? When we are back, we need to build the buff writer. Maybe, hopefully. Yeah, before I leave, what else is happening? Ooh, stuff on Twitter. People are really taking this to the extreme. For another, I don't know, like 6 hours. Writing and algebraic effects scheduler. Right. When I'm back, I will buy that domain as well, since we already have like close to half of that. So I'll put down the other half. Come on, sponsors! I want to sponsor. It doesn't even tell me like, hey, we're discarding you or whatever. And I have everything there. Even my identity has been confirmed. No issues. At the camera, we have it. Oh, I love this picture so much. Super nice. Nomad, we haven't done anything with. Trail, we haven't done anything with. Mesa, we haven't done anything with. These are very much higher level layers, right? Like this would be like Bandit. This would be like Plug for Elixir. This would be like Phoenix. I don't know if we'll get here in time, but yeah. TTY, any books or anything? Nothing just yet, but it's okay. It's Christmas season. No, anything broken here? No, that's fine. Colors, nothing broken with colors. And then blink. I guess we don't have anything here either. All right, cool. I know where I am. I know where we're going. I'm gonna take the break now. Really? Cancel the resub. All right, I can do that. Cancel approval. Yeah, canceled. I just don't know if anything else here needs to be amended or whatever. Like, request approval. My guess is that there's a queue and they just evaluate things. Did you redo something, by the way, while while you resubmitted your profile? Like refilling the settings or something? Okay. I'm out of here. I will be back in, let's say, it's 4 to 2 here. We'll do 20 minutes, 30 minutes. I'm gonna watch an episode or something, just eat in peace, and then come back. See you soon. Hello, we're coming back. 1, 2, 3, 1, 2, 3. Wake up, everyone. We're coming back. All right, where were we? Back from a break. Now let's. I think we can tweet this live. All right, uno, dos, and three. Hey, folks. Now we gotta work on a buffer writer so we can wrap our TCP, our socket, in it, and yeah, and get some some TLS shenanigans, and do cool. So now we want the room down, right? We want to write and write. Who's still around? All right, so we got our reader in place, at least the basic one, right? We want to get a writer now, so we can actually wrap our socket or turn our socket into a writer, so we can write through it instead of calling directly to receive and send, which actually do syscalls, right? NetIO. maybe we don't want to do that. Maybe we want to just have the modules. Okay, but that's a detour. We're not doing that now. Oof, little warnings here and there. So let's do the writer. ML, IOML. We're gonna do module type write. Let's see how that's done. So I guess somewhere here we will have the write interface, right? Portrait write. Like that. IO, that's the one. Cool. Trade projects were byte-oriented things. Implementers of the right trade are sometimes called writers. We need two methods. We need write and flush. Writers are intended to be composable with one another. Many implementers throughout the standard IO take and provide types which implement the write trait. Right. Cool. So we need write and we need flush. So there will be a type T, which is whatever we're typing, writing, and then write. That's going to take a T and a buffer, which is what we are writing. And then we will return results, right? Like like that, pretty much. But we also need flush, so T, and this will return a unit. Pretty much the same thing. And we will have a writer module. So we need to have a way of creating or making a writer, right? Module make, be write, and there will be struct, type T, BT, let write, be write, let flush, be flush. I am actually going to turn the TV off. She's playing on the back. It's kind of annoying. It's kind of loud. There we go. Cool. And we will have similarly, right? Let's actually start with the test here. IO reader. We'll do IO writer. So we'll open some bytes. Actually, we don't even need to open some bytes. Maybe this test is too much, actually. IO write. B. This might be better as a start. We're just creating a file, right? And instead of doing a single write, we'll do writer, right? Write. So writer, this will be file to writer, file in, and then we'll just pass in the writer and the data, and this will be the operation. And the nice thing here is that the writer can implement behaviors such as closing the file once you're done writing to it, when you do the last flush, for example. We don't need to configure that here, but possible. And then this thing is actually going to read the data. And we have this is some data here. Oh wait, reader test. Test with buffer. This is testing that we are buffered. And if it's unbuffered, all right, we can different types. Oh, never mind. So we open the write, we turn it into a writer. We write, right, the data that we have into it. And then we expect it to be there, and we can read that by just doing the same thing. File, open, read, right? File to reader, we can do this exact same thing. We get how much we wrote. So now we open the path file, right? Turn into a reader. Use the big buffer for this, right? And then we read. And then we just turn it into a string. So we can then match on the string. Test done, reader test. And I think the reader needs this file. Cool. So we started with those two. And I think we actually want to do write all. Ooh. Let's see. No, TLDR, no. TLD. Um, DocsML. Just curious if it's available. Name.com doesn't show it. Maybe GoDaddy has it. I don't know. Not available. Nope. Shady AF. Okay, this domain name is unavailable. Why? Yeah. Okay, so then maybe it's taken. That's kind of sad. Anyways, enough messing around. So we want to do a writer like we did before, and we want to go from a file to a file writer, right? Yeah, and then we have the loop there, which is fine. Cool. So IO, make, and we will have functions like let write, right? Which think I think we need a let off write source, right? Very similarly to pack together And just like we have read, we're gonna have write, right? I forget what the right syntax was for this. Okay, whatever. Moving on. So this is on still kind of hard to find, but I know it's somewhere in the bottom. Okay. So IOML, right? This complaint here. Oh, it must be in file. In where? file writer, perfect. Oh, flush here. Writer, and then flush. And this should be data. So we say write. Cool. And then we want to do all write all. Same interface actually. I think. No, we should go until the end. All right. So we have the writer here. We now need the read method, the write method, right? Okay, we'll implement that once we're done with this. Right. We'll get you in a second. One thing at a time. So this should be enough, I think, for writing, right? We can do next hack, IO, test, IO writer, test. And we'll need to go into test. Like that. Yeah, that worked. So if we read that file, then we write it perfectly. I mean, it's just the interface, right? Like, it doesn't do much. And now that we probably want to call this IO writer test instead. Cool. And now we can try to add the the buffer here. Do we even need that right now? Maybe we don't. So this will actually grab whatever you're saying, write it, right? and then the C code will take care of sort of iterating over those C structs, right? And copy everything. So this already is like write all. No, it can't be. It can't be like write all. I think this will block if you're, let's say, writing to a socket. And I think we should see that in a second. Fit sketch IO writer. All right, so this will be good for the writer, I think. I guess, yeah, will it? Let's see if everything else works still. Should. Right, we need that removed. Tune format, run again. There you go. So if we now go into socket, right? Network ML. And we try to provide a writer. So we have this low-level network, right? And we can probably do reader writer test. So once we get a socket, net reader writer test. test, net reader writer test. Cool. So once we get a socket here, right, we want a reader and a writer. So reader, writer. Oh, great. So we don't need this stuff. We just need to do IO reader, right? Read. Okay, we still need a buffer, right? But now this can be IO read reader, right? Read. And we can say reader, and we can pass in the buffer, right? And we'll get some data out, and we can do IO writer. Right. And that will be our writer. And hopefully nothing will change. Oh my God, that worked. That's pretty cool. So we have this common interface now for reading and writing. And now we can use it also in the connection side, right? So we could do let reader, right? And do IO, writer, write, writer, right? And I think that should. And then again, IO, reader, read, right? Reader. Cool. So this works. Net test. This would be net reader writer test. Okay, so if we can read and we can write these things, I think we have everything we need, right? Hey, Kantorin! Just saw you. Didn't have the chat I hand here. I'm building this thing called Riot. Riot. Let me go to the thing. It's an OCaml 5 multi-core scheduler built with algebraic effects, and it lets you program in the style of Erlang and Elixir, right? So you get processes and stuff like that, and it does a lot of things. It gives you almost like super cheap multi-core, so you don't have to think about multi-core at all. You just pump processes and do work, and the scheduler figures out like, oh, we need to distribute them right over this cores that you have here laying around, right? So everything works like for free for you as a programmer. Performance-wise, it has a cost, right? It is not ideal for like CPU heavy things. Like if you need to crunch numbers, this is not the scheduler you want to use. But for IO things, it should be amazing. Right now, it's all right. It's only 3 months old. Has a lot of work to be put into it, right? Yeah, but that's what we're building, and we were building an HTTP client for that required some lower level work. So we ended up building reader and writer interfaces, right? So we can generically like build pipelines of reading and writing to be able to do things like TLS and whatnot. And I followed the lumberjack, everybody. Thank you so much for following. Oh. Yes. Some time ago, I would bother, right, to I guess at least try to hide it. But right now I don't care. It's like if the R's are R, I have an R that's kind of weird for Spanish as well. Like most people will say perro, I say perro, ro. That's from the north of Argentina. People make fun of us for that and other things, but yeah. No, I'm not really going to FRP. Like honestly, this is just so you can build efficient pipelines of data, right? When you need like low level pipelines of data. I really, really don't want to build anything that's like type heavy or. Honestly, I'm trying to make this thing. Sorry, yeah, this thing and Riot as productive as working with Elixir. And you don't really do FRP or things like that in Elixir. You just like spin up processes whenever you need the concurrency, right? And inside a process is like boring, dumb sequential code. Is it functional? Yeah, right? But it's as close to functional, like it's, if you put a spectrum, right, on Go without mutating anything, right, and Haskell on the other side, then I would say Erlang and Elixir are closer to Go in that sense. They're like bare minimum, right? I was like maybe even like I would say maybe Lisp without mutation, but I like the idea that Go evokes in people is like a language that's like dumb and practical, and you can build things in it, and then a lot of stuff gets built in it, right? So more like that. ¿Qué tal acá? Is it good? In F sharp, okay, cool. Well, Lumberjack, thanks for joining the chat as well. Well, excited to have you here. If I can help out with something, just ping me. Let me know. The stream is kind of a mess. You can see like there's stuff everywhere. But yeah. We're trying. All right, so we go back to Blink now. Because now we can actually do some cool stuff. We don't need read and write here anymore. Maybe we do. I don't know. We need to figure out how to do this. But what I do know is that we won't have that like a file descriptor like that anymore, right? I think we're gonna have a stream socket IO writer T. Wait, why do we have two types? This could be T, writer T. Why did I do T there? That makes no sense. That is so much better. And same here, every time we see a T, we can say source. And then this becomes T, right? Okay, I need to be able to refer to the old one as well. That's fine, we don't have to actually leak that one. So we can use reader here, right? And here. It's really the same type, so it should be okay. But reader T. Oh, buffer T, reader. Maybe buffer needs to be outside then. 493 562 T bam bam. Cool. All right, so that should do the same thing. So doing tests, we can run all the tests. What do we do? No, we created the writer. Did we create the writer? No, we implemented writer for network for sockets. Fit impl writer for sockets and test it. You could use more tests for sure. I'm gonna push a branch. Install everything. Whoa, Bunny was CMD and Conturn. Thanks for the follow, folks. Welcome to the caravan. No, I haven't used Akka before, but I've done a lot of Erlang and Elixir. Would be really nice though to try Akka in F sharp, right? And see what kind of abstractions they have and stuff like that. I really wonder how they did maybe F sharp has had continuations for a while, right? Fibers or something like that. But OCaml just got them like this year or last year maybe. What's the system? Okay, yeah, I think we have field int. Right. So we want to have a writer here. In this case, it's file. It's a file descriptor, right? Um, so net and socket. What the fuck's happening? Come on, LSP, you're doing terribly. Yeah, this is the time of the night where I get cranky. So blinkml. Writer. So we'll do a net. There you go. Socket to writer. And then we have a file descriptor there, and then reader, and then to reader. Ba-da-da-da. Don't really care about that file system anyway, file descriptor anymore, right? Cool. So now we can do writer, write, and we can do the writer, push the data in there, and so making a buffer of C struct. Oh, we're just perfect. So we're just like wrapping that. No data being copied or anything like that. Cool. Still, I think we could wrap that in there. $169. So we're trying to read, and we want to buffer. So I think we can do the same thing. Buffer, right, of C struct, and field's going to be 0. Two, 3. Wait, what? Why did we do that? We want to call read, and we want to be able to passing the receive buffer. But the receive buffer, okay. IO buffer T. There you go. 171 and buffer sub. And this will be off, right? And then this will be len. IO buffer. Buff. .243 IO buffer length. We don't expose that one, do we? Yeah. About length T int. What else do we have there? We have this card, consume. Look at this. So many nice little functions. You're gonna put all of those right here. I think it's safe to put all of them here. Whoa, what was that? 258? Of course, it's yet another representation, right? So we want to do IO buffer, right, as big string. Well, I don't know, maybe we don't really need to do that now. So this is for sending the request, write request, and then write big string. Hey Counteron, just reading your messages. Interesting that they're doing like higher level things. It reminds me of like Orleans in C#, and maybe that's sort of part of what inspired the Akka people to have a version, right, for C#. Um, how I got into OCaml, I've been writing rather large Erlang systems, and I started to feel the pain, right, of working with untyped languages more and more and more and more. You need to write so many tests and stuff like that, and it was just like the natural next step. I did a talk recently about how I think that OCaml, right, was just a perfect fit for how I think. Not because of some idealized version of reality or whatever, but rather because the compiler, right, just helps me keep on track and helps me move along, right? And having ADHD, it's just been really, really hard, right, to to work with a lot of complexity in systems where I have to remember things all the time, right? And I have to pay. I don't know if attention is the right word, but having a type system, it's just been a game changer. Yeah, I'm hoping that the talk will be really soon, so then I will link it everywhere and so on. But most likely I'll be sharing the link on Twitter. So if you're on Twitter, you can find me. It's the same username as here. Oi, phone go blocked. Yeah, glad to hear. I really don't like that we have all these different versions of the same fucking type. Big string. Same. If I go back and we do C struct, look at that. The buffer, same. It has a little more around it, right? But I don't know. It would just be nice to, if you're gonna make a new type for that, right? Then just make sure that you can just go back to the older one. I think so. I think that it lifts the ceiling, right, of complexity I can work with. I can manage so many more things, right, when I have types. I understand that not everybody works that way, and I'm not going to claim that types are better, right? I'm just saying they're better for me. And when I need to build software, right, if I have types, amazing. I understand that a lot of people get really, really put off by them, and that's fine, right? These are the kind of people that build amazing things in dynamic languages, right? I'm just not like them. I can't do that. Or I need to put so much more effort to do the same thing, right? So all I'm saying is it's yet another tool that we can use to make the computer do things that we would have to do instead, right? So the talk I gave around this was about developer accessibility, right? How do you make things for developers more accessible? Not in terms of ARIA or colors and stuff like that, but in terms of APIs, right? And putting that complexity, that burden on the computer. And how we've been doing this. Like we were very, very, let's say, interested, right, in making the computer do more things for us. And we reached like the mainstream programming, it just reached a ceiling at some point, right? And we're talking maybe Algol, right? If you look at an Algol program, or if you look at what the compiler would do for you, is not so far away, right? From most model languages, right, that are typed, in the kind of things that you could do in a parallel timeline, right? Milner would have discovered ML earlier, maybe, right? Or Hindley in that case. And we wouldn't have ignored it for like 20, 30 years, right? We would have actually banked on that. But then again, there's a reason that there's some people, right, that are neurodivergent, right? And it's the least of them. That's why they diverge, right? So in some sense, it makes sense. But this is all hand-wavy, spacious arguments. So what I need to do here is just need to convert our IO buffers, right, into a big string. So I'm going to do as big string, right? I don't really like that, but I don't know if cstruct has a way of turning that into a big string. I don't think so. The big array. I like that because I can work with that. As cstruct, right? We do that. CS cstruct, and then we do big array. Just please don't copy that. Tell me it doesn't copy. Okay, shares the underlying buffer. Excellent. And that means I can put that in there. Boom. Because a big string is a cstruct buffer, right? Which is an inner buffer for IO buffer. We definitely want to change this though. We want to swap out this this parser for the co-HTTP one. Fuck, that's what we wanted to do. Somewhere here we had a big there. Okay, so we started here instead of here, but that's okay. We can finish getting the TLS and to, oh my god, we did so much. That was a big detour. $15 with the and you're not human. Where the hell are you? Come join the stream. I am a didgeridoo now. Okay, so TLS has that, and that means if we need to, oh yes, I think this is what I want it to be. I don't know yet. Probably is gonna fail, but now that we can make a request, right? We don't need to do net socket send, right? We just need to write a request into the writer of inside of TLS. So we'll do IO writer, right? Right? And we'll do writer here. And once we don't want to serialize a big string, do we? Yeah, okay, we do. And this is our big array, which is a big string. So now we can do cstruct of big array, right? Offset 0. We're gonna need the length of that, and that's gonna be a big string AF length BA, right? And this is gonna be the cstruct. Oh my god, this is hilarious. And then we'll do IO buffer of cstruct. And then the field amount is going to be the length. Right, there you go. Cool. Of big array. Like that. 287. Sorry, this is just so funny. Buffer, IO buffer create with capacity, call it. And then instead of receive, we're gonna do IO reader, right? And then read. And we will read into our buffer directly from the connection TLS, right, reader. What do you think of CPP const expressions? Honestly, I have not used const expressions in C++ or in Zig, which they have comp time, right? I think it's super cool. I like compile time stuff. I like macros as well. But you know, Be careful. Yeah, that should work. We get a buffer there, and oh my god, we're gonna have to do the same fucking dance to feed it a big string again. Here. I did not realize I was recording a macro. Uh, yeah, I don't know what's gonna happen if I press macro run now, so I will not do that. Honestly, I have not used C++ enough uh, to know like about this template patterns you're talking about. I did start programming in C and C++ 1,000 years ago. Must have been like, I think I started with C++ when I was like 8 or 9. I got the C++ programming book by Bjorn Strostrup, right? Written in Spanish, like translated. Um, I think it was my last year of primary school or first year of, I don't know. And I did some video game stuff, right? Early in my career. But I haven't done much there else since. I moved on pretty quickly from that. I think my cable is kind of broken. This one over here. It's a little wiggly and sometimes it just like loses connection. Well, that's nice to hear. I'm more excited about Rust, to be honest, but okay. So I think we need to go into the interface, and we have a couple of big strings, and this will be IO buffer T. Blinget. Oh no. IO buffer to string. Ooh, look at that. Get a camel org test. 55. 55. Okay, it compiled. So I don't think this is doing what we expected to do yet, but we already have a writer and a reader, right? So we would once we now that we have that, we can look at how TLS EIO is built around their flow type, because their flow is essentially a combination of a writer and a reader, but you can parameterize that, yeah, single way and two-way flows, right? I need 1 second. Be right back. And we're back. Okay. So essentially, what we're still missing is the wrapper, right? So if we run the test for get OCaml TLS, then yeah, response parsing error. So when we call stream, right, we have issues here. We read 31 bytes. What did we read? Looks like it's the same. Maybe we don't really need this. With OCaml, you're in a better place. I don't know. Did I already react to this? Maybe I did. So we do the writing here, and that just calls our write, right? And then we do the draining, and this is a little loop, right? It would be hilarious if we didn't need to do any of the stuff we did in the last 10 hours, right? So let's go to mirror left, OCaml TLS, and we're gonna look at TLS EIO and raw. Yeah, see how they have the flow here, right? And they're doing these single reads and stuff. So when they do client flow, so you already have a flow for this? Wait, so this returns a flow. No, it returns a T. Oh, oh, copy files. Okay, I can do that. Interesting. We could learn from this and build similar tests for us. So we return a T, right? That's what this returns. And this is our T. Or we're not returning this T, but we return this T over here. Yeah, that looks like that. We have an R, right? Right. So we're wrapping our handler, right, on module raw. And then source sync and shutdown. This is how we tell EIO. Use this module when you want to read from this thing. Use this module when you want to write to this thing. I don't know. It feels more complicated. But essentially, it is what we want to do, right? We want to start the client, build our T like we just did, and we want to be able to wrap it up in something that we can read and write from, right? So we definitely want to have like a to reader, right? And to writer. So we will save these things here, right? But we need to keep those fields there. But we would end up actually using this reader and this writer, just like in EIO we're using the source and the sync, right, to get stuff done. Now ooh. I don't know how this wanted this implemented. What did they ask? Oh, okay. So read method, single read, single write. That's literally what we have here, right? So this is doing get ops raw. No, we want to find the function of t. So we'll do IO writer, right? Make. We need to make a writer here. And I think we can actually probably do that out here, right? So we want to include type T, which will be our T, so non-rec, right? And we need two values here, right? We need a right, and I think we actually have a right there. And a flush. Which I don't think we're gonna implement. Cool, this makes more sense. So what are you complaining about? Perfect. What's the problem? Right, this one over here, it needs to actually return bytes. Okay, one sec. So we can do that, that's fine. We're writing directly through CS, but our stuff works with a buffer, not a C-struct. And we do still need to handle that, right? So we need to return the amount of bytes we wrote. I am gonna need to expose the writer, right? Of write source. And let's pull that interface. There you go. Ball. And this will be more like and we'll need the same one for the reader. Reader T. Doom format, Doom build with D, feed expose, reader, writer, packers or creators. So now we'll get those in, right? In just a moment. There you go. Of write source, and we can say modal write, and we can say T. That's the thing that we're gonna be able to write, right? So now, when we connect and we get a TLS, we can say TLS Unix, right? To writer, TLS, and then we get a writer, and that writer is the thing we're gonna be used to actually do things. And we're gonna get a reader as well, so I'm gonna put that in there. TLS Unix. So really this was gonna be read writer. I think it should be that, but IO writer T, and then reader, one of those. Cool. And the same thing will happen to this thing, right? It'll be read, and we'll just make a reader. And we just need to offer a read method here. And I think, yeah, it's the same signature. So IO reader of write on source, so module read, we pack that with a T. And off we go. I think maybe there's some errors here. int is not compatible to that. So yeah, of course. This one is returning an okay. Cool. So 175. Two, 4, 3. Now that we have those fields, right? We can read, right? Reader.read from what? We're using them. What do you mean? Oh, I'm sorry, that's the wrong reader. There. And writer.write. Now that one I believe you were not using. Okay, almost there, almost there. Now we just need to make sure that this write function does the thing we expect it to do, which I don't think it does right now. Like it should drive, right? The dude with the beard. Is this, are you gonna ask me if I work at Jane Street? Because I don't. But I've had two separate people on two separate days being like, bruh, talk to me about Jane Street. I know you work there. Didn't we used to talk at Jane Street about that? So I might have a doppelganger. Override source, all this stuff is working. Looks okay. So, okay, let's look at the differences, right? Justin, I don't know, that's not me. I can barely grow a beard. So, yep, not me. Ah, look at that. Yes. Yes. Okay. That's the stuff. That's the stuff that we're missing, right? Because before, we were looking at the write operations, right? Like this one, that were happening during initialization, right? But then when we need to actually pack this into something that EIO can use, that is where we're not even using the same call, right? We're working with something entirely different. And that thing that's different, right, is actually calling the TLS engine here on the right, right? Which is excellent. So you look here, single write takes some buffers, which is an array of C structs, right? And a T, which will be the TLS struct with the engine inside. And then it will do things. And those things are things that we need to do that we're not doing. And this is why it's not working. And now that I say that out loud, I think I am so happy. We just spent 11 hours building writer and reader infrastructure for Riot so that we could get to the point, right, where we find what's missing. It's crazy. Fuck, I love programming so much sometimes. Ooh. All right. So that's great. We're just going to do the dumb thing here. I'm going to grab that code. I think it doesn't depend on anything else above it. No, I'm just going to grab that. And we're going to copy. It's not going to work at all, right? But it will give us a starting point for modifying it. So single write, we can go like, okay, write is going to be single write, right? The interfaces are not even the same. So we need to come here and be like, okay, you're going to get some data. And right B here, it takes a list of C structs. We could actually convert it into a list of C structs. Oh, this is Leia, by the way. Mwah. She's the cat I'm cat sitting for. She's adorable. She's so cute. But she also is not allowed here near the computer. Come on, you know what to do. Leia, walk away. Are you tired? Should we allow her to just sit here and hang out with us? She may press a bunch of buttons. Sometimes she farts. What do you say, chat? I do all the time. The problem is that she's like 1,000 degrees. Oh my god, like half the viewers just dropped after that. All right. They don't like you. Whatever. Okay, so I'm gonna need you to do something differently here. So how about we do this, right? You lay there like you usually do. Get comfortable. Give her some love. I do, all the time. I feed her, I pet her, I brush her hair, I make sure she has fresh air and goes outside. I'm cat sitting her. It's not even my cat. And I do all the nice things. The other day, I went in the middle of the snow to get her wet food because she loves that. You farted already, didn't you? IO buffer S. Oh my god. Chat, it's in help. She's right there, right? Can't do much. I'm gonna add a stream marker here for later. Jesus. what is the problem here? Int is not all right. So single right. There's all of that stuff, and we just need a. Okay. Cool. And now the read becomes single read, right? Which obviously is not the interface it expects, but whatever. So buff is gonna be IO buffer, right? As struct buff, and then it should be almost the same, except it recurses. All right. Fuck my life. So T the buff, right? And then we'll do that, and then we'll just call T buff. And this returns an int, so we're actually gonna do an okay there. Oh! Oh! Look at that! We fucking did it! Woo! Ladies and gentlemen. Leia doesn't want to say anything, but yes, we has done it. This is actually reading through the reader and the writer, through the TLS engine, and into the socket. So that was 11 hours and 10 minutes now. Well spent. Woof. We still need to keep it working, but I mean, there's still some things to do. But at least this is actually doing something. We got a response there. And I'm going to try with other websites now, like, for example, OCaml.org. Let's see that one. All right, so let's intense now because I have to use both hands. You okay, Leia? You comfortable there? You want some cuddles? Ah! So cute! She's so fluffy! Alright, so get OCaml.org. Really, the test is should be in OCaml.org, like that. No! Why? Google.com? Does that work? Also, invalid chain. Why does my website let us do that, but the real websites don't? We even get a response back. 200 okay. Where's the body, though? God response. Is the body empty? What are we missing here? Content length. That is the entire content length. Okay, so we can probably close this. I don't know. You can say what you will. I think we have the better abstraction here, reader and writer, like that. We can mix them if you want, and make like an IO whatever, just like an IO thing, IO thingy, IO thingy. So we want to read the body, but the body for some reason is not full. Why isn't the body full? We are parsing. So at some stage here, right, the body should be what's unconsumed in the request. So I would expect us to have this here. I think we might want to have different buffers for reading and writing, but those will likely be internal. Let's do some logger here. debug ff body, right? And then we'll do IO buffer to string body. Let's see. Okay. There's stuff here and it's empty. What? A big array. BA buff. I am hacking your fridge. I am hacking your bank account. There's no zeros. I mean, sorry, I'm tired. Pretend that was funny. Can you get me a beer? No, no, dude. BA buff. What the hell? Body buff. So that's printing something. I don't know what, but what is happening here? Why are we not getting the data? Maybe that's because we have a really big buffer. We read, and I guess once we read, it will depend on the reader that we use, right? So we're using the network reader, and the network reader, what does it do? It just calls receive, and then as it receives, it fills the buffer with data, right? And it calls, updates the buffer with the data. What if we use a very small buffer, like 100? What do we get there? Cool. So that is the body has stuff there, right? For streaming data back. So if we do a 124, we got some stuff to come on. I am confused because the body itself, right, once we read, it doesn't seem to have much. But maybe the reason I'm confused is that done, right, just finishes parsing when he finds a double RN, right? 2 new lines. So I need to manually continue reading, right, from then on. But since I already have the headers here, I can look at the content length, right? And be like, oh, so I need to read another this many bytes, right? So I'm gonna go with that assumption, thinking that that is the right thing. So HTTPAF headers, and I want to get content length, right, from rest.headers, and this will be a string option. I kind of need that, right? Content length. Maybe you ate too much. Cool. So now that I have the content length, right, I can do a little loop here, right? Read body. We can do body, right, and just create a buffer with capacity content length, since we know we need that, right? And here we're just gonna call read, right? I think at some point we're gonna get if len is 0, if we read 0, then we just end. Or if it's bigger than 0, right, then we recurse. Unit. All right. Else, okay. Int of string. No, parse. String to int of seriously? Int of string. Logger, debug, fine if fine. About to read byte to body. Content length. That sounds right. 35,000 bytes. So we have that body, and then we do reads. by 6. No, we're missing a bunch of bytes here. So why does this stop? So to reader, single write. So going to write B. You know what? We're gonna start adding those infamous however, do think we should start with the read flow. Single read. We probably will see many of those. Yeah, single read, single read, single read. So what's up with single read? So no linger, right? We're going to read react. Okay. I think if we are reading here, single read. Because we need to interface with C structs like this, we might need to do some manual bookkeeping. So CS, if we turn this into a CS, right? Then there's a chance that we can do buff, which is a buffer, right? And we will, I think, maybe buy a buffer consume, right? And then we can pass in the amount, which would be CS, I think it's length. It could be the offset as well. Could be the offset plus length. Same here, or did I go farther? No, we still just get those five reads. Okay, so my guess is that if we print out, right, like here, handle, and we do something like the position of the buffer, right, and the field of the buffer, right, then IO buffer position, buff, IO buffer field, buff, then we will actually see the difference between that and here where we have consumed it, right? And we can say CES, and this will have an offset and length, and that will be CS off and CS len. Cool. Position. What is this? We were listening to Kiss yesterday. Damn, that's a pretty fast field. My guess is that we probably have enough. Two four two eight plus 2848 plus 4570. 31. Off you go. Okay, so this is not really modifying that, which is good. So I guess he is right. Is really? All right. If we get some data back, then we will use that. But it looks like the CS and has the same length as whatever we are reading, so it must mean, right? Can leave it there. But it must mean that this buffer here, right, already got modified. Right. So this is a subset of the read buffer, of the receiving buffer, which is completely fine. So we call handle react. Sorry, read react. And then we have a handle call, so that means we go down here, right? We're still active, we read something, and then we go into the subbuffer, right? We cut down that buffer by what we actually managed to read, right? Which is great. And we just say, okay, deal with that. And this line is superfluous because we already know how much we actually got in. So here we're just reading things, right? We may come up with some data that we need to write back into the flow with something like this, like CS write, or some alert or error, right? And then we'll do it right there. Let's see, maybe the problem is that we're getting a 0 here. So exception, write or closed. Which is fine. So if we log some other things, because we have about to read body, so this means we were done reading the entirety of the headers, right? So we did one read, and we managed to feed the 677 bytes, and then we grabbed what was useful from there, right? we read from that connection, and we got 655 bytes that for some reason are empty. Maybe that's a problem now. Like, I would expect that buffer to be filled with stuff. So we only see one of those. Okay, let's see. The reader, I'm gonna open that here. Damn it. The reader is defined by this little module read, right? And it will do a single read on that. So we should probably do len here, right? And return that len. But we want to tell this buffer, right? Buff. Right, we don't want to do consume. We actually want to mark this thing as filled. So we want to do of cstruct, right? And then field's going to be the length. And then CS will be the cstruct. No, that's not what we want to do. This will create a new buffer. And we don't want to create a new buffer. We want to modify the existing buffer. So once we go into this raw mode, right, we want to be able to do set field, right, buff len, like that. Okay, so let's add that, right? Val set field, right, and we'll do t, and then field will be an int, and then we'll just get a unit because we're modifying that thing. And set field t, and then field, and that's gonna be t field, right, and then we'll do field like that. Let. We have position consume, which is good, right? Now, Leia. So cute. Look at this. Look at this. Isn't she cute? Yes, she is. Okay, but if you're gonna keep farting, then I'm gonna toss you away. Okay. Not gonna lie, having a pet like this around, right, keeps me sane when Sweden is so dark and so cold. Super nice. Okay, so when we do IO field and we do set field, right? Then we're gonna set field into the minimum of field, right? Or capacity, because we can't really feel over capacity. So feet allow manually modifying buffer field state. OCaml install that. So I think that's what we want. Because we're reading into the buffer that you're giving us, right? We're not really creating a new buffer. So we need to be able to move that pointer around. And this would be filled by length. Better, right? You see, we're like, now read actually has stuff in there. So one bug less, I think, I hope. And maybe we don't need to do this at all, right? Maybe body has... No, I don't think so. I think we're just reading exactly as much as we need. And once we find a double new line, then we're like, all right, we're good, we're done. Keep doing the rest yourself if you want. So this should be pretty straightforward. It's not really manual. Hello again, Leia. Came for the OCaml, stayed for the cat. Ryan, I cannot get you a beer. There are no beers in your fridge. Just 0 bytes. You are trapped. Where you gonna go now? You heard something. Yes, you heard something. Am I crazy or these numbers actually add up? 8810 plus 12816, right? And then 1424. That's a lot. That feels like more like when we need to read. Why did we read this much? So much cat hair. Oh yeah, I did say Ryan. 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 Hi. Hi. So I don't get though. Why are we? Let's say we remove the buffer for a second, right? We just read from the con reader. And now we have 2848 plus 15664 plus 7120, right? Plus 5269. So we're missing a little bit now. Oh, this read more than we needed to. So then maybe it doesn't always read exactly that. sometimes reads more. Which makes sense, right? Because we have a buffer that we're feeling, and partial doesn't really know what to do with that. So when we get a body, we get, let's say, prefix, right? And prefix length is going to be big string, AF, length, prefix, right? So we'll do content length is going to be whatever we have there minus, right, the prefix length. And that is as much as we need to read. I think that's just that, right? We don't need to do much more. Need to read, and then, oh wait, my allergies are killing me. You hear me, Leia? The allergies are killing me. Right? I'm about to read. Need to read out of bytes. So need to read and then content length. Wait. Content length will just be the body, right? That is the end of it. We read the whole thing. We read the whole thing. But why are we not finished, though? Why do we keep doing stuff? So if our accumulator, right, goes above the need to read, then we'll just tap out. There we go. That was that. Like, we just need to make sure to understand that, okay, if we need to stop reading, we stop reading. Also, what the fuck did we do with the website? I think it could be bigger, but we can do equals. So this buffer, this does not look right. What do we do here? It looks like we're, like the body's chunked. Oh, right, we're missing the prefix. That's fine. So we want to do IO buffer copy, right? And we want to source, and the destination will be test buff. And we'll do source. It's going to be IO buffer. Of cstruct, right? And we'll do let cs is going to be cstruct of big array, and off is going to be prefix of, len is going to be prefix len, and then prefix ba. It's going to be a big array. So I think that should buff of cstruct, and the field is going to be prefix of. I can just do cstruct Leia. Come on, quiet. Length of cs. So that's our source. Copied. Still missing a bunch of the input. Though we copied a bunch at the beginning of the buffer. And it's okay. I think it's a good senior programmer, right, question to ask. You know what I mean? It's like, so read body, we're reading these bytes, right? And we just need to read, let's see if that adds up, like 3474 plus 1393, right? We're still missing bytes. I don't know where they are though. I guess maybe they're here. 1424. So minus 3474. You know what? I think I'm doing the math wrong here. So instead of doing that, I'm just going to go big string, right? Length. Prefix. And of course, this is not a big string. So we're going to start by making the prefix just be a buffer. And then we can ask things about that, like buffer length. Leia, come on. Stop kicking things. And that's almost what we want. I don't know if it's accidental, but it has a lot more content, right? So 31129 plus 1393, 32522.